Akshay, are you around? Hello, Akshay. We just announced in the Telegram group saying that we make some important announcements. We'll start in less than a minute. It's 7:05 already. Okay, 7:06 we'll start. Akshay, are you around? Akshay. Somehow there's very less response. I believe there should be around 100 students as per our poll yesterday on who will be in the beginner's bus and who will be in the Caravan Camp. I suppose there wasn't any miscommunication anywhere. Can the volunteers please help me? Can we go ahead? Is the number realistic? 52? Nupur, anything wrong? I'm sorry. You people...
Let's wait for a few more people to join it, because we generally have a lot more people.
One second.
Can you tell me once again?
Could we just give it a minute or two? Wait for a few more people to join it.
You're not very clear in a way.
She's asking if we can wait for like 2 more minutes.
Yeah, sure. Not a problem. Just announce on all possible places that we're starting in 2 minutes. Meanwhile, if there is any question from anyone else, please raise your hand. I'll be addressing the question meanwhile. Is my voice clear? Is the video clear? Voice clear? Okay, perfect. Any questions? Any questions, clarifications? Please raise your hand. Yeah, Nishkarsh, you can unmute and ask me the question if you want to. All right, maybe some people who wouldn't want to join the session may see the YouTube live, or they may see the recording later. So in that connection, maybe we needn't disturb them. We can start off. Okay, so I have kept given that there are very less people, I'll keep the mute all option enabled, but you can unmute yourself. Allow participants to unmute themselves. Okay, and the chat window also is open for anyone and everyone. Okay, all right, so let's go ahead and start the session. Okay, so welcome to the fag end of the beginning of the Caravan Camp. I started off with something, I ended up with something. And as they say, life is what happens when you're busy planning it, they say, right? So even such events are also what happens when we are busy planning it to make it perfect. So it helps for us to keep the ideas open so that we don't fixate on the direction, but we sort of diverge to perfection, right? Okay, so we started off with some 3 to 4 sessions of me discussing some of the nice, cool ideas in computer science. I thought the response will be average, but first day I saw that it was way above average. With time, I realized that this was, greatest show ever, at least in my experience as a teacher. I was thoroughly impressed by looking at all your enthusiasm, interest, appetite to learn, and also the stamina to sit and go through a long session, especially the one that went on up to 4 a.m. in the 4:30 a.m. if I'm not wrong, 3:30 or 4:30, somewhere there in the early in the morning, and we did bid by saying good morning. Right? I will never forget this as a teacher in my career. I don't think this is ever going to happen. Also, probably it will happen if we meet each other often. Anyway, that's a great testimonial from my side to the entire BSc course. I'm sure it is to attract the best possible students. The kind of students I've had that I've seen for the past 1 week is a lot of hard work for the team, and goes without saying. I think big claps to the team from my side, and I'm sure all your side too. Okay, so with this, let me start off with some announcements about what's coming tomorrow. Okay, with time, I have been observing that different people belong to different bins. Some people are at the beginners level, some people are at the intermediate level, some people are at the advanced level, some people are even more hungry to do some very challenging questions. For instance, what I gave yesterday as the tracing question was not straightforward, but I was impressed to see some of you attempt. Most of you did not get it right, but very happy to see that you people have attempted. And the promised chocolates will reach you. We were busy doing the Caravan Camp discussions today. I didn't take a look at it, but I'll take a look at it eventually. There is actually no deadline. Please go ahead and shoot your program anytime, but ensure that you write your comments and docstring properly. Otherwise, we will not consider the code, obviously, because it's difficult for us to understand what you do. Okay, so go on. The first 10 people will get chocolates. Maybe I may even extend that to a first few people, about 10 too. As of now, I have not got 10 yet. So please go ahead and then shoot your code. You still have some time. Okay. So coming to tomorrow, in my personal opinion, it could be a life-changing experience for all of you. Just participating there, not doing anything but participating there. Okay. There's a difference between watching a movie on a television, watching a movie in a film theater, being amidst the actors and seeing what's happening there is a different, thrilling experience altogether. Being on the stage and being part of a drama or a play is a different experience. So what you'll be doing is the last one, not just watching a YouTube video and coding along. You will be doing with a team, organized bunch of activities, which is a good conglomeration of mathematics, statistics, programming, data structures to some extent, and a lot of logical thinking. All these things happen, and you'll be amazed to see that it happens when you're in team very fast. Learning is really exponential when you are in a team. They say if there are n people, the productivity is n choose 2, because any two people can interact. You see, if any two people are interacting, you will be watching. If I see Sai, Pranav and Nupur talk, I'll be watching them talk. I'll be learning from what they're talking. So bigger the n, bigger is the n choose 2, which is roughly n square, n into n minus 1 by 2, as you know. Mathematically speaking, this is a very well-known fact that when you're in a team, the productivity is quadratic and the learning is exponential. Okay, so with this, I would like to tell you what's going to happen tomorrow. As I said, it's going to be a life-changing experience, at least according to me, in my opinion. You should not miss this. What are we going to do tomorrow? We're going to have 2 different tracks. Track number 1 is Caravan Camp, which we have been planning from a long time. I'll be giving you a bunch of functions to code and a bunch of volunteers who have tried coding this, knows in and out of it. They will help you code it. Okay. By the end of the session, you would have finished a mega project. I don't think you people would have done a project so far, a project that does not involve simply coding or development of a small application or a big application, but also involves an ingenious scientific or engineering idea. That's what you'll be doing tomorrow in the Caravan Camp. And some of you have registered, some of you are in the question mark state, whether to participate or not. You are eligible if you have come till functions, and if you have tried coding a few functions and you have understood something like binary search and attempted at kth element, if not coded it completely, you're eligible for the Caravan Camp. Please come on in, welcome aboard. Okay. If not, if you're struggling with the very basics, if you find if loop, for loop, while loop traumatic, then I don't think you should come there, because it might demotivate you. Please come. You're welcome. Talk to me in case you didn't get an invitation. I'll help you get an invitation, but then it can be difficult for you. Okay. In case in doubt, the benefit of doubt should be to not come. Let me tell you. Okay. And we have a parallel track, which is the beginner's bus. That's a Caravan Camp, okay, Campavan rather. And on this side is a beginner's bus, where it's going to be a huge bus with many volunteers trying to help you from the very basics of Python. It is important for us to hit a reset button here and there. So they're going to start off with the first day of the code and do a very hackathon-like session with a bunch of 7-8 questions. They'll take you through. And only limited people will be there, some 8 to 10 people per batch, or maybe maximum of 20. Not more than that. Average of 10 is what, right, Nupur, we have decided. But then a number will be small is what I meant. And one volunteer will handhold you and help you finish a few ideas. Okay. So as of now, we are going to declare the documentation for marathon so that anyone who is interested can start reading it right away. Right, Nupur, only volunteers knew the document. Now we can share the document with everyone. Correct? Or maybe we shared it already with a few people.
No,
right?
we have only shared it with the volunteers.
Oh, very good. So please go ahead and share it with all the registered CC people as of now. Okay. The beginner's bus will only go through the basics. And who are these beginners bus people? We all start from the first step of a mountain, right? Or first or second or first few steps of the mountain, and then we climb up. So you are in the first few steps. We will ensure that you very soon climb up, and also do a CC very soon, a campus, Caravan Camp very soon. Just that we don't want you to get demotivated, because of which we are putting you into the beginner's bus. And the bus is going to go really fast, assuming, knowing what is your pace, respecting your pace. Okay. And by next week, I'm sure you will be ready for another hackathon session. As I said, this is just the end of the beginning, but it definitely is the beginning of a very long session that's going to come ahead. Okay. In fact, very interestingly, I had a chat with the admin recently. We are also trying to see if we can have a course in this style, where it's merger of several ideas. So we discuss statistics, we discuss linear algebra, we discuss machine learning, we discuss data sciences, we discuss programming, data structures, and it appears like a puzzle that you solve, and all these subjects, they come and go. That way you get the maturity to see what is stats, what is probability, what is math, what is linear algebra, what is calculus, what is programming, and how all these things come together beautifully as a dish made of different ingredients, which whatever I mentioned above. Okay, so this is also happening. That's sort of a good news. That's the outcome of this boot camp that we did for the past 1 week. Looking at your response, I think we are planning to see if we can make it really formal and even give you credits eventually. I mean, it's not yet decided. It probably will be decided in about a week or two's time. Nothing is final yet, but I'm just breaking the ice right now itself that this is coming ahead probably. Okay. All right. So getting back, the beginner's bus will go slowly and then quickly pace up, and eventually you will be put to Caravan Camp. Yeah, Anupur, assuming there's something important. Yeah. Go ahead.
I'm just dropping the link to the Telegram group for the beginner's bus over here. Please note that if you're joining the beginner's bus, try to stay in the beginner's bus, attend this session, and there is always a Caravan Camp for you in the next week. So here's the link. Sometimes Zoom doesn't redirect to Telegram, so try to copy paste the link in your Google browser. That's an easier way to do it. Second thing is,
bring your mic close to your
I'm sorry, is this better?
Oh no, still there is some noise cancellation happening. Anyways, no problem.
Okay, I'll try my best. So the link is in the chat box. You can just join this group if you want to be in the beginner's bus. We will have a session along with the Caravan Camp tomorrow, and we will touch the basics like Sir said. And again, a word of caution, if you're in the beginner's bus, you cannot be in the Caravan Camp. So that was it.
Correct. So that's an important announcement, all of you. Nupur is trying to say whatever I told her a while ago, that it's important that we practice mutual exclusivity, trying to be everywhere. You know, a hunter who catches 2 rabbits catches none. Putting 2 legs into 2 different boats doesn't land you anywhere, right? So try to be in only one thing, and we will ensure that one thing. Second thing is we're bringing in the following rules, that you should put a display picture as well as your name there, because there are a lot of anonymous people discussing, and sometimes it can even become a hindrance for our discussions. So let us not have any anonymous people. You should have a proper user ID, a display picture, as well as your IITM ID should be visible over there. Okay. By the way, the recent Telegram mailing list has a lot of outside people who are not part of IITM BSc program. They keep pinging me, and I keep asking them. After a minute, I get to know that there's someone else not part of the program, which is also okay. I don't mind people coming and then discussing, but it will be noise for you people. I cannot concentrate. Instead, the same time I could give it to you. My time is very limited. First preference is for my students. And if I have more time, I can go outside my students, right? So in the interest of all of you, we are coming out with this rule. Still, if you want to remain anonymous, you can stay back in the same Telegram list that we have right now. Notifications may also be posted there, but mainly we'll have 2 different Telegram groups, one as Beginners Bus, one as Caravan Camp, and suggest that people ensure that you be in exclusively one thing. And after you are done with Beginners Bus, move to Caravan Camp. Okay. And whatever event we are doing tomorrow, the Caravan Camp will be recurrent. It will be done again and again and again. Okay. Maybe even beyond your semester. As you know, these things have nothing to do with your semester or credits or whatever. So it will go on and on. Don't be in a hurry to, learn things. That is where we make a mistake and we never learn stuff, right? Go very slowly. We are creating different modes for different people. So be in the beginner's bus. This is basically the announcement for tomorrow. Caravan Camp will involve teamwork, and I want you all to actively participate. There'll be intense coding, intense thinking, intense reading, intense logical reasoning too. Okay, that's pretty much what we wanted to discuss. It starts at 11 a.m. and goes on maybe a little early through the night or late in the night. I don't know. It depends on you and your group. But I see that beginner's bus should not go beyond early evening, but the Caravan Camp can go a little beyond the late night. I'm not so sure. It depends on you people. If you don't give up, I'll not give up. I'm with you. Okay, so let's make it a very memorable event. Please keep posting all your selfie pictures of you working on your desktop tomorrow on the group. Let's make it fun, at the same time also memorable, and a lot of learning will happen. Trust me, it will be a life-changing experience in my opinion. Okay, any other detail which I think I would have missed right now will be posted on the respective group, so don't break your head. Okay, this is pretty much the announcement. At this stage, maybe we can stop the live session too. Akshay, if you're there, you can stop it. And after this, what's going to happen is I'll take a Q&A quickly for 5-10 minutes right now. And after Q&A, some of the volunteers who are preparing for tomorrow will come here and then prepare in the Zoom call. Okay, Atharva and co, Atharva, Mehul and co. So Ashik, I see the volunteers here. Srijita and co, the CC volunteers, you will continue in the live session. Okay, I want the event to be memorable. I want this to be recorded. Also, I want this to go live. That volunteers worked and they're preparing for tomorrow. Don't worry, anyone who sees it will not be able to make sense of what's happening today. So it's just like a trailer and the teaser for what's coming tomorrow. Okay, I hope things are clear now. Let's go ahead with some questions quickly and then wind up so that you can get back to your work. So Nupur and co, the BB volunteers, feel free to walk out anytime you want because you have less time to prepare for tomorrow. Okay, yeah, go ahead. Rajneesh.
Hello, good evening, sir. Sir, my question is, I read one document in Telegram in which it was mentioned that IPython and Spider would be used tomorrow. So do I have to install or I can code in Replit also?
You can code in whatever you want. There's no restriction. Okay. Although in the instructions somewhere you would have read that, but don't break your head. It's not a condition. Every single session that we are doing is very informal. Okay, do it the way you want. In fact, some of you, if you do not want to code also, we are perfectly fine. You just stay there and watch others code, copy paste others code, and then see how it works. It's okay as a learning experience. You're just seeing how things work at the higher level. You first drive the car and then learn how to, change the stepney, then, repair the car. And even the final part is manufacturing the car. Let's not get there. So let's go slowly. No restrictions. You do it the way you want, copy the code, just be around, sip your chai. Don't even be involved if you want. We are perfectly fine with it. But the volunteers will be, splitting their face off to ensure that you all learn it. If you come ahead, they will also come ahead and then help you out. Otherwise, do it in your style. No problem at all. No fixed rules. Absolutely for tomorrow. Okay. Yeah. Next question. Raise your hand, please, if there's any question. People are busy joining the group. I guess I see a lot of notifications coming on the group. Any other question? If not, good. Go ahead. Let the volunteers start. Okay. Priyank, quickly. Go ahead. Unmute yourself. Yeah.
Hello.
Yes, Priyank. Priyank, yes.
Yeah. Good evening, sir.
Good evening.
Sir, actually, I didn't have a question answer session, sir, but I was actually looking for some advice from you, and I thought that this might be the perfect time, sir. Actually, I am right now in diploma level, and I have completed my Python foundational level.
So we all are in a festival mode right now. Hackathon only. Okay. If there's any other question, please post on the Python Caravan Camp and we will try to reply back.
All right. So actually, it was just advice kind of. No, sir. It's okay, sir.
Okay.
Thank you.
Yeah. So yeah, we are in Diwali fire cracking kind of a mood. We don't want to play Holi now. Okay. Don't mind.
Okay.
No,
it's all right.
But I'll give you my share of time. Okay.
Okay. Yeah. Thank you.
Just message me directly on Telegram. I'll reply back.
Okay, sir.
Yeah. Syed, please go ahead.
So I don't have problems with like while or if. I could understand the functions, but I couldn't join the camp tomorrow because I have NPTEL exams. So do you suggest that I join the beginner's bus or should I continue with it?
No, if you don't have time to join tomorrow, whether it's beginner's bus or Caravan Camp, it doesn't matter. Right. So go ahead. Good luck for your NPTEL exams. That's also important. Finish your NPTEL exam. So, you have been a good student. I don't think you will find it difficult. So please come back and we will be conducting beginner's bus once again sometime later and you can join. Okay. Some other day. Good.
Thank you.
Amit.
Sir, I didn't get the link for the Caravan Camp.
Yeah, it will be announced right away in the chat window by one of our volunteers. Okay. So ensure that you people get it. Mehul, can it be announced right away? Hosts and co-hosts can. So maybe you people can. No, you will get it, Amit. We are ensuring that everybody gets it, right, Mehul? Everybody gets it. Okay, so it will come to you right now. In fact, it has come already on one of the groups. Okay, yeah. Please go ahead, Dev. Pritodeep.
Yeah. Good evening, Professor. Am I audible?
Yeah, very much, very
Yeah.
clear.
I just wanted to clarify. We were sent a link, a Google form link in the Telegram group. Will filling up that form, is that considered as registration?
I think so, right, Mehul?
Yeah, so the Google form which you filled, it was just to have a brief idea of what your level as a programmer is, and we'll give you the registration link soon.
We'll be
Okay.
giving you the registration.
Oh, that will be sent in the Telegram group itself, right?
Correct.
Yeah.
Correct.
Okay.
It will be sent. Prithvi, 1 minute. What mic and earphones are you using? It not only looks good, it's also very loud and clear. I wish that this really matters when we yeah, it's not of any use when I mute you and then ask you to tell us. Okay, go ahead.
Can you hear me?
Yeah, I can hear you.
Yeah, it's a Logitech H390. It's a USB headset.
Oh, USB headset. See, that's the difference. The typical jack headset, it cannot transfer a lot of data. USB does.
Yeah.
Anything that's USB based will give very good clarity. So, what's the cost of this mic?
I bought it 3 years back. It cost me around 3.5K, 3,000, 3,200.
Out of the budget of a student generally, but still try to see there could be a very optimal mic and earphone. See, why I say this? It's very pleasant when the voice is clear for every one of us.
Thanks,
Otherwise,
Professor.
the kind of mic we use, the built-in mic and things like that, it's very hard for all of us.
Actually,
right? So it makes a huge difference. Yeah.
Actually, I was forced to buy this because my 3.5mm jack it broke. So a USB was the only option for me.
Yeah, mother is a necessity. The mother of all.
Mother of invention. Yeah.
And Amazon purchases too.
Yeah.
Okay. Nice talking to you, Prito.
Thank you, Professor.
Thank you. Yes. Go ahead.
Sir, what is the problem of the solution?
What is the problem of the solution?
That piece was being thrown.
Solution of the problem. I'm just
Yes,
kidding. Of the problem, which problem?
Sir, the piece one. That the peas were thrown on
The piece one. Yeah, we will get back to that. Lori celebrations later. We are worried about Diwali Eve now and the eve of Diwali. Okay, the solution is cute. It's nice. Try to look up closest pair problem. Okay, but it's going to be hard. It can be demotivational too. I will cover it sometime. That's part of the agenda. Okay, sometime in the forthcoming. This camp will continue in a very different way. We'll take a break and then get back to the camp once again. Okay.
Yes, sir.
So it's wheels on the bus go round and round. Rhyme you have heard, right? This the caravan camp, the camper van rather keeps running. Okay. Yeah.
Yes,
Good.
sir.
Take care. So be there. Yes, tomorrow you have been a sincere student all this while. You have been participating. So I would like to see you, with your camera on and the globe in the background, going on and down with your questions. Good. Cipher now. Go ahead.
Yeah, there's a question in the chat asking if tomorrow's hackathon will either be live stream or recorded for later viewing.
Neither, because there will be breakout sessions. It cannot be recorded. So we don't want to record it. Okay, makes sense, no? And also people are very hesitant if it's recorded. Someone wants to ask a stupid question. Stupid questions are very important, but it may be conceived as stupid and they may not ask a question if it's recorded. I myself, I censor many of the things that I otherwise will be talking if it's a live or recorded session. So let's not sow this seed of fear in people. We'll keep it unrecorded. Okay, but we'll have some sessions which will be recorded where a bunch of us sit together and then do the forthcoming sessions maybe with smaller numbers. Yes, next. Anyone else? No more questions? Good. Praneeth?
Sir, am I audible?
Yeah, you're audible.
Yeah, yesterday you were talking about a book which will be required to go through the first 2 chapters.
Yeah, it's reaching you now. Are you part of the CC?
Yeah, I am in the Telegram group. Is that
okay? Let me announce the book right away here itself. It's called The Code Book. The Code Book by Simon Singh. The Code Book by Simon Singh. Those who are on YouTube live may not be able to see this, but I think you got what I said. The Code Book. Okay, code as in coding, decoding, code. Code Book by Simon 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 Singh. Singh as in sing. Okay, good. Okay, Praneeth, if you're done, maybe you can. Praneeth, Prito Dev, yeah, please go ahead.
Yeah, sorry for coming back. I should have asked this the first time. Actually, for us, those who are in the diploma level, tomorrow is the date for assignment submission. So I just want to suggest that if the next time it is held, maybe the assignment dates can be kept, that scheduling can be done so that it does not clash with the Caravan Camp.
Okay, so with all, politeness, don't worry. Don't mind me saying this. I didn't mean to offend anyone here, but no will be the answer, because there's never a day when all of us are free. And my time especially is very tight. Okay, this is the only week I'm free this year. I made myself this free. Okay, so where I'm completely with you guys only, not doing anything else in life.
Sure, sir.
That, I mean, this is a great thing to do in life. I didn't mean to be negative here, but yeah, it's difficult for us to plan an intersection of all our time, which is always an empty set. Okay, so
Yeah.
let's go ahead and try to minimize it and create an approximation algorithm which gives us a nice sweet spot where we finish stuff. But we will not be very oblivious to constraints. We will take a look at the constraints, and then I realized that there'll be some deadline and things like that, but it's a review week. I thought you're relatively free. Right? Of course, deadlines will always be there, but relatively you're free this time. Anyway, I'll keep that in mind. So I'll talk to all of you before this.
Sure, sure. Thank you, Professor.
No problem. Thanks. Next. Any more questions? Please go ahead. Anything? No? Good then. So let's switch to the primary volunteers of Mehul and Co. For what's coming tomorrow. You guys can get together and start discussing. What I'll do is I'll become the host right now. I'll log in as host. Okay, and make you all the co-hosts, and then disable mic and chat for others. And you alone will be talking, and let that go on the YouTube live stream. Perfectly fine. And others will not be able to ask anything, because anyway, they're going to be there tomorrow. Okay, I want this to be a memorable event, and I wanted to record your discussions. It's actually fun to watch you guys discuss. I was watching you people this evening. It's a very healthy atmosphere if a bunch of peers sit and discuss. Any university where this happens will become a rising star very soon. Okay, so probably is already a superstar. That's why people do discuss in such a place, right? That's a very healthy trend. So let's encourage that. Okay, take care. Bye-bye. See you all tomorrow. And as I said, it's a life-changing experience. Please make yourself completely free for tomorrow. Take care. Bye-bye. Maybe we'll take a break and then come back, Mehul. Huh? Okay, I'm back with a different name. Okay, so I will now make some of you the co-hosts, before which I'll mute all without the ability to unmute themselves. Okay, good. And the chat window, let it be open, not a problem. All right, so Shrujita becomes a co-host. How do I make you a co-host? Oh, I'm not the co-host. Akshay, are you there? Akshay? I'll just call Akshay and make him. So meanwhile, you people can start, just so that.
Just to be clear, I wanted.
Yeah, go on. Go on. Just to be clear, one second. I muted you accidentally. 1 minute. Yeah, unmute yourself, Hardik.
So, sir, just to be clear, you are asking us to do whatever we were doing on the Google
exactly
Meet to do
exactly
the same
that's
thing
it.
here, right?
That's it. Rest is in my mind. You don't worry about it. You go ahead. Okay.
All right.
Why this is for a different reason. So you go ahead. Whatever you are doing there, you do it here until the last minute. Okay. This is also going live on YouTube. Okay. Go ahead. Start.
Okay, sir. So, whose turn was it? Who was writing
I
the function?
was sharing the screen.
Yeah,
I
Madhuganda, you go ahead.
My screen is visible?
Yes. Yeah.
So I was getting an error here because of this lower function we use. I imported the file solve.txt from here, and if I run this, I get error in line 16 and line 10. Okay.
Yeah. So can you just run it and show us what error it is?
Yeah, I'm running it again. It says that there's an error in line 16 and line 10. And
actually, it is not visible.
Your entire screen is not visible.
Mother shows
freeze
when the
like
program is running.
You,
The shell.
you need to make sure that your console or that whatever the result portion is also visible.
okay, wait.
I guess an error here is that f equals to open file name, comma, we should put our mode, right? After that, we can solve that other issue of the codec one.
Yeah, you should specify first file name comma r, and if you could spell out what the error is, if you can make it visible to all of us, then it would be better for us to help you debug.
Yeah, so here's the error. It says line 10 has an error, which is the lower function we used instead of uppercase to changing uppercase to lowercase. And the line 23.
Okay, so it must be saying that is alpha does not, there is no, the str attribute has no is alpha method, something like this.
Wait. No, it just says there's an error in the text strip s equals to file.read.lower.
Okay, who's saying that this error is coming up? Because on the screen I cannot see this line written.
Yeah, same.
You're pointing out to some line that is not written on the screen. So who's talking?
I am all. You can't see my terminal. right now?
No.
No.
I think your terminal is frozen.
Your screen is stuck
Your
right now.
cursor is not
Please
moving,
restore
and
your
Sir, VS
yeah.
VS is open. Visual Studio Code is open. So guys, meanwhile, let me just put you people into the loop. So we were discussing about the statistical aspects of the big text, and I'm expecting you all to try coding that. Okay. The moment you reach the cryptanalysis part, see, encrypt you should do, decrypt you should do, cryptanalysis you should do. Cryptanalysis is without knowing the password. By knowing the password, you encrypt. By knowing the password, you decrypt. Without knowing the password, you decrypt. That is cryptanalysis. That's hacking. Okay. So get to that stage. Once you're able to hack, stop there, give me a ring. I'll pitch in and tell you the next level. Okay. So I hope we are on the same page. Yeah, go ahead.
Yes, sir.
Okay, now is it visible, my terminal?
Yeah. So
Yeah.
all right, got it. The second last line is the actual error that is bothering you, right? The Unicode decode error.
Line 16 also has an error, line 10 also has an error.
Sometimes it happens that there might be a lot of errors popping up, but but none of those
There's
errors
only
will
one
make
error,
sense
yeah.
but there's only one error. So in this case, the error that's to be looked at is the Unicode decode error, the last one.
Yeah, the last one, Unicode decode error,
Yeah.
car map.
Yeah.
So,
So go to
I'll just go back to the
go back to the code. I actually shared the syntax for the open function in this case, and should I share it on the chat or something?
Just tell her.
Yeah, so you could write it where you have written f is equal to open file name, just add a comma. Write in single quotes, write R. Single quote. Yeah. Just exit it, write another comma, and we'll enter another parameter.
Sorry?
Just write R, then write small p.
Small p.
After the R, add a comma. Now type encoding. Encoding, EN, the word.
Oh, the encoding word.
Yeah. Encoding equals.
Yeah.
UTF.
Now in single quotes, write UTF hyphen 8 hyphen 8.
What does it do?
Just try running it and I'll tell you first.
Okay.
Let's see if this fixes the error.
Yeah, it does.
Perfect.
What does that function do?
So see, I too didn't know that this thing happened in real life, but I actually just searched what error it was and I checked what the people at Geeks for Geeks say about it at Stack Overflow. So people have suggested that as we move across OSs and across different word editors or different text editors, they store the file in different kinds of formats. Right, so the file, for example, when you store music, there is MP3, there is.
So was there a Unicode error here?
Yes, a Unicode error.
Okay, that's a very first time when you see it, you will realize what's the problem, and then you will not face this problem ever again. So was it a plain text that you had stored in? Sherlock.txt was in plain text, right?
Yeah.
So when you maybe it became Unicode. It generally should not happen. Anyways.
So we had to somehow circumvent the problem by specifying the encoding that we are trying to.
So I had a doubt that this problem occurred because of our file, or is it a special type of syntax used for when we define a function?
Yeah, so
that's actually the better question to be answered. That is what I'm looking at.
Because after defining a function, I have also tried opening a file first time, so I'm not sure about that.
Can you repeat the question once? Ashik, can you repeat the question once?
Yeah, I was saying that after defining a function, our syntax should be in this way So that was the error that caused, or it was the error while opening the file. As in this sherlock.txt was encoded in some other format. So that caused an error, or our format should be in this way particularly while we define a function.
The Sherlock.txt was in some other encoding. Yeah.
Yeah. Because it is
the best thing that I have found out that works the best for me is whenever some kind of an error pops up and you are just suddenly afraid of it, just copy the entire error and search what that error is. Because usually in the language documentation, there is always a complete description of when that error is going to occur. And you just read through it and you search and you just compare it with your code, what is the most likely of these errors is.
So had this file been in the normal format, we would not require to add this another parameter of encoding, right?
We shouldn't. I think so.
Maybe. Yeah.
Thank you.
Okay, so it runs around now, right?
So guys, I have a feeling the reason why this error is throwing up is, can you go up? Can you go up? When you say f.read and then say lower, okay, so you get a lot of things done there, but f.read is in a different form. When you say s equals f.read, it becomes a string, and on that you can do a lower. Correct? Correct? Is that what is creating the problem? That line was the problem, right? Because you did the 9. You did the 9 with UTF-8, correct?
Yes, sir.
Okay, so if try removing encoding equals UTF-8 and then say s equals f.read.
I did that, sir, actually.
Sir, I did that on my computer, but that even didn't work.
As in, for the lower function,
okay, so later on you guys can hack that part. Try to avoid encoding that is not plain text. Okay, later on you can come and remove the black box there. Okay, as of now let it be a black box, don't worry.
So this one's working now, right?
Yeah, so the first function is working properly. We can move on to the next one. Should I
Everybody
stop
coded
sharing?
it. Yeah, stop sharing. Everybody coded it. Everybody's okay.
Yeah.
Just let's hear
I
from
coded
everyone.
it with that first principle, which we were not using that dot lower in the read line, right? I used the whole method to check whether it is a lower or not, and that worked.
Okay,
it's
guys,
fine.
now I might be making a very silly error, but my code isn't working. Please, can somebody check it out?
Yeah, share the screen.
Yeah, sure. Share your screen.
I think it has something to do with getting the file sherlock.txt here. I haven't done that and I don't know how to.
You need to import the file on the Replit.
You haven't called the function, right?
Not yet. But when I tried, it wasn't running. I just deleted the print statement.
So do you
First
see
upload the
plus file button on that? Yeah, upload the file over there.
I don't think you can upload the
link. Yeah, you need to download it and
then
upload it.
Wait a second. Sorry for the unnecessary delay, guys.
It's fine. No problem.
While uploading,
You can drag from there directly.
Click on the 3 dots, and from there you upload the file. Yeah. That.
Done? Oh, okay.
Now call the function.
Try calling the function.
Sherlock.txt, right?
Yeah, in quotes.
In quotes.
Okay.
Single quotes.
Package
I think
update.
that has to do something with this poetry.lock and pyproject.tum.
Yeah, I also think so that the package files are making some.
Can you delete the packaging files?
So what exactly do you need me to do?
So
Like the
the
package
poetry.lock and PyProject. You can delete those files. Yeah.
Oh, perfect.
Yeah.
Damn. Okay, thank you guys.
So like
Let's
everyone
move ahead.
understand what the function is and the code is. Does anybody has any problem?
Yeah.
Yeah, move on. Yes.
Okay, let's move to the next function.
Guru Raja has raised his hand.
Yeah, if you read the function definition that sir has given, in it's only mentioned to remove special characters. So for instance, the Sherlock.txt contains information which also has numbers like year. When they are talking, Sherlock and Watson are talking, there is mentioned. So it is
no,
critical
in the
information
last
which
line.
will get lost.
In the last line, it is written what remains is only the lowercase letters. Emphasize on letters.
Whereas we're just calculating the frequency of each alphabet. So we don't need the numbers or any other special character there is.
We are not concerned with the content of our file. We are actually doing something else.
Yeah, so basically the whole agenda was we need a big text file, and only the text strip would only give us the one big string in which the entire content is summed up, lowercase.
But the content also, it means the relevant information should be there within the content.
No, we are just calculating the frequency of all alphabets.
Next step, what we're going to do is calculate the frequency of alphabets only. So why need the numbers, right? That's why we did this step.
If you want to do something else, then we'll do it differently. But in this case, we're doing just that. So we'll just keep the alphabets and all of them in lowercase letters.
Clear?
If we want to keep the numbers, then we can also do that. If
I get the
it is
idea, but,
numbered and
that
then append into the key, like we did with lowercase elements. We didn't make any changes. We just appended it.
Yeah. Guru Raj, is that clear?
I think he'll understand when we start doing the other functions as well.
Cool. Okay, so let's move on to the next one. Hardik, you there? Okay, he's away. He'll come back. By that time, I'll share the screen. Okay.
Sure.
Okay, so no, other than that, just a second, guys. Yeah. Okay, so the next function is, I'm audible, right?
Yes.
Letter distribution. So does anybody have any doubt or difficulty when it comes to this function, letter distribution? What we do is we are taking the string which we received from here, Sherlock.txt. Now we know the string from here is completely put it into lowercase. Here we are going to check the frequency of each and every alphabet. Clear?
Yeah.
Okay, so who wants to code this one? Anybody
I
who
have
thinks they are
actually-
underconfident?
Okay.
No, Anushka, go ahead.
No, I was saying that I've actually written it, so it'd be faster if but it's better if someone's not confident with it.
No, we actually need to code it along, right? So we can, all of us
Yeah.
can teach me. So who wants to opt?
Or I can code it again from the
Sure,
beginning
sure.
if no one
Okay,
is
yeah,
willing
Anushka,
to
do
it.
that, yeah.
Just a suggestion.
Yeah.
Yes,
Before coding, can we go along and discuss the pseudocode?
Yeah, sure.
That how we'll be operating, and then one of us can code, and that would be better, I think so.
Okay.
Actually, we have already discussed it before this, so we are.
Yeah, actually, that's why we were going ahead with it. But sure, we can just quickly brief through
I
it.
was saying that in this we have to create a dictionary. So are we creating the dictionary inside the function, or are we creating
Yeah.
dictionary outside?
So
That is the thing I was saying.
we'll initiate the function and we'll create a dictionary. We'll assign 0 to each of the elements. So we have 26 letters, right? So we'll have 26 keys in the dictionary. We'll assign 0 to each of those. Uske baad, we will iter through the entire string and we'll keep on adding in the dictionary. Okay. Adding the count of each letter in the dictionary that we already created.
Just a suggestion. In further
Yeah.
functions also, we will need to create a separate dictionary for each letter of the English alphabet.
No,
So I think it would be better if we create this. We can create different function of creating a dictionary for each of the English alphabet. So because I can see in further functions also, we would need to create a dictionary with each letter. So that would be better if we create a function to create a dictionary with each letter of the English alphabet.
Actually, it's a one-line code. I'll show it to you how I did it.
Sorry,
If
but
it
I didn't
doesn't
get
make
your
sense.
question, Arshit. Can you repeat?
Okay, while Harshit and Ishan can discuss, Anushka, you can just go ahead with sharing the screen and everything.
Yeah. Okay.
I was saying that we would again and again we would need to create a dictionary, such a dictionary.
Okay.
So what we can do is we can, following the modular approach, we can create a function that gives us such a dictionary. So because in further functions, we won't have to write that same code again and again.
I would
However
like
small
to
it
add
may
on that, like in that function, we need to return a dictionary. So
Yeah.
the dictionary we will be creating, we need to return it and we can store it in the main function.
Right.
So that we can use it in later functions.
Yeah, we can define a function of creating such a dictionary. That was the case I was saying. Or you can go ahead with your own too.
I still didn't get you what you are suggesting. Yeah.
Can you
Saying
just
that it will
show
be-
us?
Yeah,
Can-
Anushka, it's visible.
No, I was just saying that we can write this a function as a function which gives us back a dictionary, and in that dictionary each key is the letter of the alphabet A, B, C, D,
Yeah.
and
Yeah.
value are 0. Because
Values
There
are
is-
the
there
frequency.
already what he's saying that you will have to create such dictionaries in every function. So he's saying that let's write a function to create such dictionary. What I'm saying is that there already is a function for this. It's inbuilt and we won't have to do it again and again.
Okay.
Yeah,
Okay.
Okay. Sure.
Yeah. So basically, we have to return a dictionary with count of each letter in this. So सबसे पहले तो we initiate the dictionary. This is the function that I was talking about. Dict.from keys.
Wait. First, we'll have to define the alphabets. Okay. This function everybody is familiar with?
Yes.
All the lowercase alphabets too.
Yeah. So after this, we initiate the dictionary. Dict.from keys is the function. Now, can you see this? Iterable and the value. I don't know what this type thing does. If anybody knows, please explain it. I know about the iterable and the value. यहाँ पर iterable will be alpha and value we will initiate 0 for all the elements. Okay, so when we run this, we basically get this dictionary. Just one line code. Okay.
So I have a easy method which can be easy on everyone's mind and is doing the same thing, of course.
Okay.
So can we go and write that, like everyone can understand that?
Yeah, Ishant, go ahead. Tell her what it is.
So inside the function, create an empty dictionary.
Okay.
So what I'm trying to say is we will append the dictionary as we encounter the letter. And if it's already a key in the dictionary, we will increment the value by 1.
We can do that too. Yeah.
It will be easy on everyone's mind.
Yeah, Ishant, go ahead. Tell her what to do.
Yeah. So now let's iterate over the elements in the string.
In alpha, right?
In S.
We are okay, friends. Can I disturb you?
We will iterate over alpha, right?
Yes, sir.
Yes.
Can I? Anyways, this code is pretty easy. What you do is you initialize the dictionary with all zeros, A, B, C, D up to Z, insert 0, and then do plus equals 1. That's all. Every time you see it. Okay. So do the following. X in alpha, correct? Colon, come down. Colon, come down. D of x is equal to d of x plus 1. D of x plus 1. D of x plus 1. Go up. Up. Enter. For x in alpha, colon, enter. D of x equal no previous next line d of x equals 0, correct?
Yes, sir.
That's it. So you initialize this to 0 and then you do the plus and return d at the end. Anyways, so I will quickly finish the plan for the day. You guys are going good. That's what I observed, right? You will be able to finish in no time. Okay, but the crux, the nucleus of the discussion, I'll finish now quickly. Is that okay?
Yes, sir.
So that you know everything and you can go ahead and then finish the coding. Okay. The idea is that of Vigenère cipher. Okay. What do? You take a letter and you substitute it with some other letter. That is substitution cipher. Vigenère cipher is the following, where you.
Anushka, can you stop sharing a screen? Thank you.
Okay, one second. My speaker Scarlett. Okay, can someone talk? Say just hi.
Hello, sir.
Okay, it's audible. All right. So now here's the entire algorithm, which means you can go ahead and then solve it all by yourself. Okay. The algorithm is the following. What you do is you take every single letter in the plain text. Okay. Based on the substitution, you put some other element, correct? Now what you do is you do what is called the Caesar cipher. Okay, Caesar cipher means simply shift, that's all. You just shift. Okay. My name is Sudarshan. My name is Sudarshan. Okay. So what you do is every single letter gets shifted by 3 units. M, N, O, P. M becomes P. Y, Z, A, B. N becomes M, N, O, P, Q. Making sense? A becomes B, C, D, so on and so forth. Vigenère cipher simply says that you're not supposed to change the letter by constant factor. You should vary the change. Here it was 3, 3, 3, 3, 3 shift, 3 shift, 3 shift, 3 shift, 3 shift, correct? It says, don't do that. Do a 2 shift for this, 1 shift for this, 4 shift for this, 7 shift for this, okay? 3 shift for this, again 1 shift for this. And then repeat this 2, 1, 4, 7, 3, 1, 2, 1, 4, 7, 3, 1, 2, 1, 4, 7, 3, whatever is the plain text. Keep repeating this block. That way you're not shifting by the same length. If you shift by the same length, you're simply doing a substitution. Anyone can use the frequency attack, whatever you're trying to do right now, and then figure out what is the plain text. So vary this, keep it as a password, a small length password, replicate it, and then do the encryption. Make sense? All of you follow? Raise your hand. All of you follow? Excellent. So now there's a very small variant to this. Instead of the numbers, you simply encrypt by let's say a word which denotes the number. Okay, so let's say you encrypt everything by Radha. Okay, R-A-D-H-A. R stands for A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R. 4, 5, 6, 6, 3, 18. R stands for 18, which means this will move by 18 steps. Okay. A stands for 1. Y becomes Z. That's all. D stands for 4. My name. N becomes M, N, O, P, Q, R. What was this? M became something, no? 18, M plus 18, whatever that is, I don't know. Okay, and H is A, B, C, D, E, F, G, H, 8. A becomes simply I. M, A is 1 step. Okay, M becomes N, and so on, which means your password is some valid English word. This you must decrypt. How will you decrypt is the question. Okay, I'll tell you the basic algorithm. I'll not tell you how it works. I'll tell you the algorithm, but okay, we can always think of an algorithm, kth largest element. You know the algorithm, but to figure out how it works was not easy. Okay, so look at this. How does it work? Am I clear? Any questions so far? Feel free to ask me questions about this. This is called the Vigenère cipher. Okay. Questions about this quickly? Clarity?
Sir, can I ask?
Yeah. Ankush, wait a minute. Volunteers only. Please don't mind. Okay. All volunteers done?
Yes, sir. Clear.
Clear? Okay.
Yes, sir.
Yes, Anushka. Anushka, are you a volunteer? No.
Yes, sir.
You're a volunteer? Okay, go ahead. Go ahead.
Sir, isn't isn't shifting by word the same as shifting by pattern?
By number?
Yeah.
Yeah, it's the same. Absolutely the same.
Okay.
Definitely the same. But then, yeah, it's easy to remember if it's word. That's all. Okay, so I keep Radha as the password, or Anushka as the password, or Hardik as the password. Okay, or Egypt as the password. That way it's easy on the mind. So the point is that you will be running a frequency attack by looking at what's the most frequently occurring letter and assign that E. But you know what? You're in a fix now, because I am changing the letters based on where it is. Sometimes the same E is shifted by Radha, R-A-D-H-A. Depending upon where it is, it gets shifted by that letter. If you keep, instead of Radha, abracadabra, or Indian Institute of Technology, Madras, that being a password, it becomes close to impossible for anybody to run any kind of an attack. So you think. Okay. So now I'll tell you how to break this password. I mean, how to break. Someone has now given me a text based on this so-called Vigenère cipher. All right. Okay, guys, please don't mind. I discouraged people from asking questions because these chaps are already, burnt with time. They should finish discussing everything, wake up early tomorrow, and then throw a good show. So in the interest of time, I said no. Please don't mind. Okay, so now I have a huge plain text encrypted using Vigenère Cipher. You cannot run frequency attack on this. Frequency attack, E most frequently occurring. You cannot do that, right? But you know very well that the first letter here, is being encrypted.
Sir, we can't see your board.
First letter here is encrypted with some number, and the k+1 letter is also encrypted with the same number. Assume your password was 1, 2, 3, 4, 5, 6, 7 units in length. Okay, let's say Anushka is 7 letters. Okay, so if it's Anushka, you know very well the first and the 8th letter is the same letter, A. Okay, and 7k+1 is the same letter. Similarly, 2nd and 7k+2 is the same letter. That much you know. Please note, every first, look at this. First one, 8th one, 7k+1, which is 15th one, 22th one, 29th one, all of them were encrypted with the same first letter, correct? That's what you know. If it's of length k. Now, in this, the frequency attack should hold good. All of them are shifted by only one number. So you can run a frequency attack on a subset. Even there, the frequency attack English should cough, if you know what I mean. Okay, English should cough here. Forget about the rest of the place. Sherlock.txt is too big a file. There, if you take any subset, this E being the distribution top should be the top. Take only half the novel, E should top. Take some random letters in Sherlock.txt. Randomly, you will encounter E more. If there are many boys than girls in a class, you take some 10 people uniformly at random. Amongst the 10 people also, men will be more, women will be less. The distribution more or less should hold, not always, but mostly it holds good. So what you do is, if you get to know the length of the password, you break it. Let me write that down so that it sinks into your minds. If one knows the length of the password, we can easily hack with the previous functions, whatever. Okay. If we don't know the password length, we don't know how to break. Okay. Now, the big black box is the following. The big black box. In this encrypted text, somehow figure out what is K. See, if you use Anushka, it is K. If you use, let's say, Ashik, it is 6. Okay. If you use Srijita Mukherjee, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Password length is 17. Mehul Anil Agarwal, very big. You know what is my name? My name is Sudarshan Sarala Raguraman Sudarshan Iyengar. South Indians are known to keep a long name, dad's name, mom's name, surname, my name. You wouldn't know where the person's name is. So if you take a name like mine, the vowels, etc., are also very weird because it's a proper noun, Hindi name. It's a very long password. Unless you know what is that K, you will not be able to decode it using this method. First, the black box then becomes, what's the black box? Can someone dictate it to me so that I can write it easily here?
Finding the number of letters.
Find the
length
password's length. Okay, I should write a word here somehow because I have no clue how to do that. You're just given the encrypted text here. From there, how will you find the password? That is the first data scientific invention. Okay, took close to 200 years to come out with this idea, which all of you will code in like 1 day's time today with Python. Okay, how is this done? How do you get to know the password from a random looking text which you know is used? Vigenère Cipher is being used on it. Okay, you do the following. Look at this. Sudarshan. Okay. Below this, you write all right. Got it. Okay. So maybe Sudarshan is not a good example. I must take a longish word. Okay, I'm sorry. Let's say abracadabra also is not okay. So now what I do is I'll shift it by 2 units. This is shifting by 2 units, right? And I'll see where exactly there are repetition. Okay, 2 places there are repetition. This is called the collision. See, well, like SION, no? One S is not there. Collision ratio. Okay, you look at the collision ratio. For Sherlock.txt, collision ratio will be something. Okay. Now, take your text. This is the algorithm basically. Very straightforward. So we are very close. What story so far? Vigenère Cipher. This is the method. Okay. This is the method. All right. K length and you shift. Okay. And then you can run a frequency attack on the 1 and K plus 1 and 2K plus 1, 3K plus 1, so on, provided you know what is K. If you don't know K, it's close to impossible. You cannot guess K. K can be as big as, you know, South Indian name. All right. Or it could be another big text of 100 letters. And if you're encrypting Lord of the Rings, which is a very big book with all the volumes together, or Harry Potter, it's a very big text. Still, if you have a 1-page long password, it will still work really well. Okay. So you know how to do it, provided you know the password's length. How to find the password, I'm telling you. Find the password's length somehow is what we decided. And finally, I'm telling you something unrelated. A definition of collision ratio. Whenever you rotate and keep it, the number of collisions you see is called the collision ratio. Okay. This is called the 2 collision ratio. Why 2?
Sir, because after the shift.
Yeah, you rotate it by 2. That's why it's called the 2 collision ratio. Okay. So whenever you do look at the 1 collision ratio, here we are, the climax point of the entire hackathon is here. Whenever you look at a 0 collision ratio, 1 collision ratio, 2 collision ratio, 3 collision ratio. Okay. All these are constants. Okay. It will be something close to the 3.8 or something. Collision ratio will be 3.8. But boom, the moment you see the kth collision ratio, it will change drastically. Okay. And K is the password. That's the data scientific leap. Why it requires data science? I mean, some very basic statistics, pretty straightforward. We'll figure it out. Don't worry. Okay, but right now, you know how to code, what to code, right? It is simply this. Look at the collision ratio, and when the moment the collision ratio changes, it's a constant. 0 CR is a constant. Okay. 1 CR is some constant. 2 CR is like how you saw in English alphabet, the occurrence of 2 consecutive letters. Okay. What you're asking here is the occurrence of 2 letters at ith distance, correct? You're picking 2 letters only, correct? That's what you're doing here. Rotate and keeping means what? If it is I units away, if you rotate I units and then place it down, there will be a collision. You're essentially asking the same question that you did in the beginning. What was the answer? 1 by 26. What was 1 by 26? Can someone tell me? It's little less than 4, right? Can someone compute and tell me what is 1 by 26? Slightly less than 4, 3.9.
0.3 something.
No. It's just less than 4. Just less than 4. 1 by 25 is 4, no? 4%. 1 by 26 should be just less than
3.8.
3.8. It will always be 3.8, 3.8, 3.8. But somewhere it becomes some 4.7. a drastic change, not a change in some decimal value, a drastic change. The first digit itself will be gone. Instead of 3, you will have some 4 or 5 or whatever. The moment that happens, call that to be your K, go back and look at the first element, K plus first element, K 2K plus first element, 3K plus first element, so on and so forth. Grab them, look at the frequency, you get to know E. Second best, you get to know T. Third best,
A.
Oh, everything is decrypted. And once you know that, not only have you decrypted the text, you also know the fill up the blank space. One more question, quick, buzzer round. Password. So that tomorrow, if someone uses the same password, you can decrypt it. Okay. Can you observe something? You need not take the entire text. If it's computationally intensive, take only a few pages, run this. Once the password is there, you can decrypt the entire page. If you know Harry Potter part 1, if someone has used this for on all the parts, take just the part 1, that's enough. So just scrape some part of your body, you will get to know the health condition. You need not take the entire body. This is like that, statistically speaking. All right. So now you have everything. You can go ahead. Even if I'm missing an action, even tomorrow, you guys can easily manage. Correct? I am just saying. Now you know everything. What is pending right now is sitting and coding all these things. Okay. It's very much possible. The way you people are going, I'm really amused, rather amazed to see that you guys will be finishing it very soon. I'll come and check once in a while. Okay. Yes, I hope you all understood. Any questions?
Sir, could you again explain where abracadabra came from? Like, is that
abracadabra was the password?
No, I said
Anushka, I said Sudarshan. Abracadabra is a password. I'm sorry. Abracadabra is the text. You rotate and then keep it below.
Yeah, so I took a sample from the text.
No, you did not sample. You take the entire text. See, I just gave you variants of it. You simply take the entire text. Let me just go through it once just so that it's clear. Let me revise everything for you guys. So
yes,
you
sir,
see,
if you could run it from the top, then it would be very good.
Okay,
Yeah,
so from the beginning. From the beginning,
yeah,
you know
so
what this
Also,
is?
one more request, sir. Can you share this iPad file with us also?
Yeah, absolutely. I'll do it right away. Okay. So
yeah,
why don't
so
people
this-
take a snapshot of it quickly?
Sir.
Done? At
Can
least one
someone
of
of the volunteers please take the screenshots?
Yeah,
sure.
I'm taking the screenshot.
Take and keep. If you have multiple, no problem. 2-3 people take and keep.
Yeah, at least one person say yes and I'll move ahead.
Yes, sir.
Yes, the second page is simply this. Wait, let me just wait. Second page is simply this. Yes.
Yes.
Yes, sir.
Third page is simply this.
Yes, sir.
The fourth one is, what's the black box? This.
Yes.
And the fifth one is this.
Yes.
Yes. And the last one is
yes.
this. You're done. Once this happens, you know what to do next. Okay. So let me go over from the beginning. Okay. All of you with me? Go over from the beginning?
Yes, sir.
Yes.
Okay.
Yes, sir. Yes, sir.
So we start with the shifting. And then I realize that instead of shifting, what do? I shift at different places by different digits. And how much you shift is the password. Okay. I shift with Radha, or let's say Hardik, or let's say Srijita, or Anushka, or Ashik, Sudarshan, whatever. That's the password. You shift by that level and you have encrypted text now. Whether this is encrypted text. But you know very well the first and the K plus 1 and the K, 2K plus 1 and the 3K plus 1 and the 4K plus 1 and the IK plus 1 is all encrypted by the same letter. You know that, right? So what you do is you realize that in case the password's length is somehow told to you by someone, If not the password, just the password length is told to you, you can run the frequency attack. So far, so good. Okay, so how do you find the password's length? You venture further and you observe that what is called the collision ratio. I define what's a collision ratio. Take the entire text, this entire text, not the password, the entire text. Rotate once and then keep it below and look at the collisions. Rotate twice and keep it below and look at the collisions. Keep doing it. For some kth value, it boom changes. What do you rotate? Not abracadabra. Atharva, can you tell me what do you rotate? I just wanted this to be clear.
The whole text that we are
whole
which
text
is actually
that you are trying to hack.
Yeah.
Right. That text you rotate. You keep that as a string S. You rotate and keep that as a string S1. S and S1 you compare throughout. You see where exactly there are collisions. And once you see a collision, you increment a counter and count the collision. 1 count collision, 2 count collision, 3 count collision, so on. You go up to K count collisions. And I'm guaranteeing you this. See, you don't know how this works, but I'm guaranteeing you that throughout here, it will be some value, some value, some value, some value. Immediately there's a phase change. There's a mood swing. Right? This fellow will be he'll be smiling at you, but immediately he will roar back. And that's the place you must stop. And you must say, I have found out K. Once you found out K, you know that was the black box, and you can go back and find out the exact password. Right? On to Anushka.
Sir, a collision ratio is number of collisions divided by what?
No, the rate of,
the
rate of the places where collisions are happening in the numerator, and in the denominator, all the string length. Okay. So there are n number of people in my class. K people are unable to understand what I'm saying. So the unable to understand ratio is K by n. The placeholders where you're unable to understand. I mean, the collisions, right? Obviously, it's going to be less. And you know how much it is for English. Okay, it is 1 by 26. Right, 3.8. But boom, it becomes 4.7 somewhere. A big change happens. Again, you rotate it once more, it goes back to 3.8. Every K, 2K, 3K, let me write that down, or you people make a note of it. It's not just K. After this behavior will actually continue. K plus 1, it will get back normal. Every kth day, there is a new moon day, Amavasya. Okay, it will be K only. K, 2K, 3K, 4K. Other days, the moon is visible. The ratio will be 3.8. On these days, it will be 4.7 or something. Okay, that's all. You break the password. Not only do you break the password, you also understand the password.
Sir,
right?
When you say the ratio is 4.7, what ratio are you exactly talking about?
Some change in ratio, that collision ratio only. Collision ratio changes on this new moon.
Collision is a count, right?
Collision is a count, yes. It will be 3.8.
How is it 3.8? It's a count like in abracadabra we have collision with 2.
What is the text here? Yeah, go ahead. Ashik, you explain.
Yeah. So if our collision is A, and again after some letters we encounter A and A once again, and in total if we have these number of collisions as 3 and our total text is 7, so our ratio would be 3 by 7, and then when repeated, we will proceed.
Okay, so this collision rate will always be 3.8. Once every K times it will change. That K, this is where the English coughs, the English as a language coughs, and should catch hold of it and then strangle it to death and see what exactly is your password. Yeah, Hardik.
Sir, can you please repeat the K and the K plus 1 and the K plus 2 thing that you just said? I didn't catch the drift.
So in this part of my iPad, I was just trying to tell you that if the password is of length 7, at the first place, at the 8th place, at the 15th place, at the 22nd place, the 29th place, it is encrypted by the same letter. If the password is of length 7, if not, we don't know. And all I'm trying to say is I'm sort of proving a theorem here that if you know the password's length, you then infer that the first letter, the K plus 1th letter, the 2K plus 1th letter, the 3K plus 1th letter, all of them are moved by the same number because it's the first letter of your password that you're using.
Okay, understood. So we are doing the frequency analysis on all those elements which are moved by the same K.
Correct. I was a little fast there.
Right.
I observed a couple of you getting it. I just moved ahead. I should have been a little more clearer there, but it's clear to you people now? Okay. Can I now mute and then watch you people talk for some time?
Yes.
Just to see whether, no, concentrate on the weakest link, please, not on the strongest link. Okay, go ahead. Okay, think, and then if you have questions, then you can go through the entire thing once. Someone can paraphrase the entire thing once, just so that I have confirmation that you have understood. Anybody, the strongest link, whoever that is. If you're confident, go ahead and then paraphrase it.
The whole the course that you just explained right now, sir, or the ones previous as well.
Come again?
The previous ones as well, or just ones that we explained right now?
Whatever I have said, the entire thing, the entire algorithm to break the password.
Yeah. So basically, what we are trying to do is a Caesar cipher was very simple to crack because shifting the numbers, all of them by a specific n number, we could easily crack the Caesar cipher. So what they decided was to make a more tougher,
more
Caesar,
robust one.
Yeah, more robust cipher. We would change. Let us say I take n numbers, and this n would be the length of my password, and I want to encrypt a big text. What I want to do is I want to shift each of these letters in my big text by a different number. As a result, creating a independent. As a result, each time I repeat this, am I making sense or am I?
You're making sense. Go ahead. You're making sense.
Yeah. So basically, what I'm trying to do is instead of shifting all of the numbers, all of the text by one specific number, I'm shifting them by a specific pattern each time. Like
which repeats.
Which repeats. But I don't. As long as I don't know by what frequency it repeats, I cannot say anything. As long as I don't know what the length of the password is, I cannot say anything. And the moment I know the length of the password, it becomes my same problem, which is the previous frequency problem. I can just say, I know the length of the password. The length of the password is n, and that means n, the 0th element and the n+1th element, all must be shifted by the same amount. And as a result, I can apply my previous intuition, which I used to crack the previous logic, and simplify it. But solve the whole cipher, and in the process even find the
so now it boils down to
finding the length of the password.
Super. Okay.
Yeah. And to find the length of the password, what we do is we take let us say we have our text, which is page 1. We replicate the text, shift it by one digit, like not one digit, one space, and the last element goes to the first place, the first element goes to the second, and on and on. And we check how many collisions there are, how many repeated symbols there are. And the moment there's a repeated symbol, it's we increment the counter, and we calculate the ratio of the collisions with the total length of the whole text, and that should come out to be 3.8 on a normal basis. And repeat this again and again and again, increasing the shift by 1 every time.
Correct.
And the moment we reach the kth part, the graph will suddenly rise up, and we will get a spike. And if we shift again once more, then we will go back to 3.8. The ratio will go back to 3.8. And because this is shifting by k and shifting by 2k results in the same thing, it will every time shifting by nk will give the same result.
Perfect. So this is the part 1 of the story. Okay, this is part 1 of the story. Finish it by tomorrow. There should always be a chain to go ahead with the part 2, right? Every movie at the end, a good movie will have a part 2 at the end. They'll just warm your mind. Okay, the part 2 is obviously how is this behavior coming about? What is this k? Why is this the Amavasya happening every k places? Right, is a open question that people should figure out how eventually. But don't worry about it. You just be programmers for tomorrow and finish the code. Don't be tempted to look at why this is happening statistically. It's not very difficult. It may take 1 hour or 2 hours for you to figure out, but that's not important as of now. That's part 2. Part 1, finish this code. All the best. Take care. Any other questions, please ask me. Otherwise, I have confirmed that at least some of you have understood. So I clearly see almost all of you have understood, in fact, right? So go ahead and try the coding. In case you have any questions, I'll address and then we'll go ahead. Good to see Samir doing a thumbs up there. Good to see that non-volunteers are also here who understood. So pull them as volunteers. Feel free to join in as volunteers if you understood completely, if you're able to write the code by tomorrow. Okay, I'll pull you in as volunteers too. Good, go ahead. Any other questions,
sir, I
guys?
think Hardik wanted to say something.
Yeah, Hardik.
Oh. I
no,
thought
Hardik?
you were raising your hand, so.
No, I wasn't. I was just telling someone to stay quiet.
Okay.
Oh, in your background. Okay. All right. So is that all, guys? Done? Yeah. Completely. You confirm what needs to be done? Rotation, collision, etc. is not very easy programmatically. At the same time, not difficult. To so many people are there, you can figure out. Suggest that one of you write the code and then finish it. Create a collab, Google Colab notebook. That way, it's accessible for everyone else. Or do it over Replit, all of you.
We were planning to do it. For example, I am very familiar with my ID, so we'll just together write the code, we'll formalize it, and then we'll transfer it to wherever.
Anyway. Whatever
so
you
all. We were planning that Hardik would store it. All of us would write it, one of us. But
don't worry, be familiar. Tomorrow, at least keep this code. If you understand the code, just keep this code and then.
At the end of the session, I'll share the entire code with everyone.
Yeah. Anyway, whatever you all are comfortable with. Okay. All the best. Take care.
Yes.
Bye.
Yes.
So who was coding and what function was being programmed?
Anushka was on the counter one.
Letter distribution or the substitution encrypt?
No, the counter
Second
letter distribution.
Second function, right? Okay.
Shall I resume?
Yeah.
Yeah, sure.
Okay. This should be indented, right?
That should be T.
No.
S hoga na?
Sorry, in my code I written T, that's why I shouted T. Capital S.
I have small s here.
Yeah, right.
I think the for loops are independent. They are independent of each other.
I also think it should be
Why we will iterate through alpha, no? So we'll go letter wise.
In the first for loop, we are just making a dictionary of A to Z.
Oh, okay.
In the next
first one is for initialization, right?
Right. Okay, so this capital S was a string that I got from the first function.
We're getting the repetitions. T should be maximum 30,000. Okay, go to T.
S.
Now, just scroll this vertical, horizontal scroll bar to T in your answer.
In the output, scroll. Yeah.
Oh.
Output horizontal scroll. Yeah. Menu PQRST20. So yeah, perfect.
And then A.
Okay then. So who's doing for the next question?
Did everybody understand that? This code?
Yeah.
Yeah, you can move it.
Has everybody written it in their own computer?
Yeah.
I want to ask something.
I would just request everyone to whosoever is writing whichever portion of the code should actually comment at least line by line or module by module what they are trying to do, right? Because that way, if in any case we want to refer to this file tomorrow, we are all comfortable reading it. Otherwise, we ourselves will have to read the entire code and then understand ki kya karna.
And I want to ask something, like if we don't add the first for loop, and what we do is in the second for loop, we do if X in dictionary, then initialize it.
That is also correct, I think.
If X is not in the dictionary, then initialize it in 1. If it's already in the dictionary, then increment it.
That's also right.
Just a second, guys. I'll be back.
Okay. So shall we move to the next question?
Yeah, so if anybody don't has any issues in this code, we can move to the next function. Everyone is fine with it, right? Okay, then let's go to the next function. Can you show us the next function? We can discuss it.
This is the next question. This is the next question.
Does anyone has issues with the function, like what it's doing or what needs to be done?
Don't see the solution. Just okay, sorry. So इसमें basically we have to okay, so इसमें the user will input a dictionary जिसमें उन्होंने already दे रखा होगा that A goes to this letter, B goes to this letter, C goes to this letter, and we just have to take this string and we have to encrypt it. So everybody is fine with that?
Yeah. So like the go about will be maintaining that alpha string. Then whatever this is in password is basically, right? The string will be a password.
So
Yeah, the
we
string
need
will be the jumbled string.
exactly. We need another something
So
or
we need to create a dictionary.
Yeah.
So I think that's what someone was saying it earlier, like create a different function so we don't have to create it again and again, right?
I don't think we have to create a dictionary here. We are given a dictionary here. We have to use the dictionary to create a string.
That's right. But what he's saying is, let us say, oh no, sorry, my bad.
So what I'm trying to say is like we have given the dictionary, but at present we don't have the dictionary now. So let's create it by us.
No, here we have to encrypt, right? So we need a dictionary.
He's saying that let's create a temporary dictionary that will be given as an input. So we just use it.
Exactly.
Oh, but for a test case.
Test for a test.
Okay, so I've made it here. What I did was, is everybody familiar with this? Okay, let's see. So alpha is the string with all the lowercase letters, है ना?
Yeah.
ओके अब हमने डिक्शनरी बनाई, इसमें डिक्शनरी कॉम्प्रिहेंशन से सब फेमिलियर है, नहीं तो फिर दूसरे मेथड से
I'm just saying something.
क्या
we don't have the substitution dictionary yet, right?
Yeah, we can write the function first and then worry about the test case.
Fine with me.
Yeah, sure.
Okay. So am I doing this for this function also? Or
Yeah,
is
sure,
anybody
Anushka, go
willing to-
ahead.
Okay. I'll just copy. Okay. So इसमें we will iterate through the string that we have and then go and check it with the dictionary. और वहाँ पे जिससे भी वो mapped होगा, we will append that to new list. So उससे पहले we will basically create a new empty string. Then we'll iterate through the given string. Okay. Then we'll check which letter is this letter mapped to the dictionary. And then we'll append that letter to T. Okay. So T equals to T plus D of X. ये ठीक है? हाँ.
Yep.
And then we'll just simply return T. Okay.
Yeah.
Any doubts, anyone?
Yeah, right.
Yeah, it's fine.
Okay. Now test case के लिए S तो we have. Alpha I had already defined. Alpha is the string of all the lowercase letters. Now D, dictionary comprehension से सब है familiar.
Yeah.
चीज I was चलो ठीक है, just go ahead.
हाँ, तो इसमें हम ये समझ आया है? This is
shifting it by 1, right?
हाँ, I'm shifting it by 1 अभी, ठीक है? तो this is alpha का x, जो भी x letter है, it will be mapped to the x plus 1th letter of the alphabet. बस यही है इसमें, इसको print करके देख सकते हैं. A is mapped to B, B to C, Z to A. Okay. अब टेस्ट करके देख सकते हैं तो तो एस वो वाली स्ट्रिंग है जो फर्स्ट फंक्शन से ऑलरेडी मतलब हमें मिल गई थी. जैसे यहाँ पे सी है दैट इज मैप टू डी ओ टू पी है, ऐसे ठीक आ रहा है तो मेरे ख्याल से.
ओके कूल.
Yeah, it's okay.
तो ये लिख लिया सबने?
Anushka, you're saving these functions, right? Like
हाँ.
Yeah.
We can write comments.
हाँ, right.
Guys, I'll just be back in a little while, okay?
I just have something to say. I don't know if I'm correct or not, but something tells me that this should be right. You've chosen the easier approach in this manner, that of course this is the This is the naive method to, just go through each and every element and replace it by whatever the value of that key is. What we could do is, I tested it out. The replace function, the replace method actually replaces each and every instance of that element in the entire string, right? So what you can do is you can maintain a variable called done, right?
Okay.
And you can go on replacing the element in the string if that element is not already present in done. So that way you'll have to at max go through 26 iterations and you'll be done, rather than going through the entire text.
Can you tell me how?
Sure, yes.
Anushka, what he's saying is that instead of just shifting it by 1 place or 2 place or 3 place, whatever it is, to keep a list of some alphabets and then call it and then do substitution according to it.
Yeah, I'll dictate what I wrote. Just declare a variable called done and declare it to be an empty string.
Okay.
Come to the next line, right? For I in S, if I not in done, not in should be space. Yeah, not in done. S dot replace I comma D of I. That's it, and return the S.
You are not appending the done, right?
Yeah. Sorry, I forgot it. You have to then done equals to after S dot replace. You have to write that statement. Done is equal to done plus I. Yeah.
Can we take one moment? Like, I want to test something on this function. Like, I want to make really sure, like, is it working fine or not?
Hardik, for that, could you just explain what is happening here?
But it's not working. It's returning the
You have to
same
replace
thing.
done, not S.
You should do it like S equals to S dot replace, because it's a method. Then it needs to be reassigned.
Yeah.
Now try doing this.
It's incrementing by 2 places.
Now that depends on whatever dictionary you form.
No, but it's 1, no? यहाँ पे तो 1 से shift करा है.
Could you explain what you're trying to do? Because I don't understand the algorithm.
Anushka, call it other.
He's just trying to do the substitution method only. You take a list of words, some random list of words, and you have the original text over it. So you substitute whatever is below that word. For example, you have A, B, C, D, E, F over in the upper column, and you have some V, H, M, N, O, X, something in the lower column.
Yeah, we can have that, but it's really difficult to cross-check that. No? So it's easier to cross-check when I have a dictionary of this kind. C is mapped to D, E is mapped to S. If I map randomly, then it'll be difficult
Can
to
you
Adhik sir, just a quick question. Why are you checking if I not in done?
Yeah.
Why are you checking if I not in done?
That simply means if I have already not replaced all the elements named I inside that string, then replace, otherwise just continue.
We can also say now for every letter in S dot replace I by DI. I think that would also work.
We could do that, but that would be the same thing that Anushka was doing previously.
Yeah.
I'm just trying to cut down the work that I have to do, so that at max I have to replace only 26 times.
I want to like mention something which a test case which will fail this method. So what if my character, my letter in a string is mapped to some letter which is not in done? For example, I'll give an example. Let's say my A is mapped to Z in the dictionary, which I'm okay. So first I go S dot replace A with DI. So my all A's are mapped with Z.
Yeah.
Okay. So now, for example, I have a string called A, B, B, C, C, D, D. Okay. So my A, yeah, write it down. So you'll be. So now my all A are mapped, all A are replaced by Z. Fine. And now I come to the second letter in the string, that is Z. My Z is not in done because I haven't processed it yet. So it will append it. So it will fail in this.
Got it. Yeah, Anushka, then your method is the way to go. Yeah.
के बाद यहाँ this question है substitution decrypt.
I think isn't it same as encrypt?
It's just an inverse, right?
Yeah, the dictionary should be inverted and then you just use the encryption.
Okay.
So what is the value of a key right now becomes the key, and what is currently the key becomes the value. So there are two methods. Either you use the same dictionary and
we can create a new string and then keep on.
Why create a new string?
No, we have to create a new string to decrypt a decrypted string. We can't replace in S.
Yeah, we have to create a new one. Same method.
Yeah, same method.
No, what I meant was there are two ways to go about it. As I see it, we can either use the existing dictionary, which we were using to encode.
Yeah,
we can either use that same dictionary and then write a troublesome code for ourselves, or we can simply invert that dictionary. And then simply use the encryption function that we have already written.
But the dictionary is given us as an input, so we don't need to work on that.
Yeah, that is what I meant.
Okay.
You can explain it again. You want me to explain it again?
Just a clarification. Is this the dictionary, the encryption one, or is this the key one dictionary?
This is the dictionary, whatever dictionary the user inputs.
No, the dictionary.
With the key. It's the dictionary with the key. Like the element, jumbled element is mapped to the real element.
Yeah.
So, like
no.
A is mapped to B. Is this that dictionary, or is this the dictionary which is used to decode the text?
This is the same dictionary that was used to encrypt.
Yeah, then we have to reverse the dictionary.
Yeah, then we have to reverse.
Yes.
Because if we go on writing the same, if we go on using the same dictionary and write a code from scratch to use that very dictionary and try to decrypt it, then it would be a very troublesome code. It would be very confusing.
It would have multiple loops, and it would just be extra computing cost for no reason.
Yeah, and then it would take a lot of time to debug. So what we can do is, it's easier to switch the keys and values of a dictionary, and then we can use the encryption algorithm that we've already written. Still not getting it? Okay. So let us say A represents C. Let us say A represents B and C represents D in the original encryption dictionary. If I use the encrypt function, all the A's in my string should be replaced with B and all the C's should be replaced with D. If I reverse my dictionary, that means if A was supposed to be B, I switch these values and now my B is supposed to be A. And I similarly switch all the key value pairs. So
that will become the key.
That will, yes. So earlier my dictionary was supposed to represent the current value with the encrypted value. After switching the key value pairs, my dictionary now tells me
encrypted
value and the real value. Yes. So now we have a new dictionary, which is exact opposite of the encryption dictionary. And it is the same process as encryption now. So I can simply call the substitution encrypt, give it the same string, the encrypted string, and the new dictionary that I found.
Is there any function which will do directly this? Like,
Anushka, I think you've written it wrong. It's real value and encrypted value. What we want to create is the encrypted value to real value.
What we want to create is, yes.
What we want to create is encrypted to real, and then we can just call the previous function and execute the whole thing again.
Anushka, related to the previous code.
Now?
But we have to return the string, right?
Yeah.
But
in
then
this definition,
then we'll return the encryption function, right? So whatever the encryption function returns to us, that will be returned by the decryption function.
We have to return the original string.
Yeah.
And we have been given the key. We'll use
the
same method that we used last time.
I took some text. I used a key to encrypt it. Now I have this key and I have this encrypted text. And what I'm doing to this function is I'm passing this encrypted text into it and this original key into it. What we want to do is we want to flip this key and now use this key on this encrypted text. So we can call my previous function and just be re-encrypted to be readable.
That's the testing part of it, no? The code too will be same now.
No. I'm just saying that in the quotation what you've written here, the given input D, is the encrypted value and the real value. It's exactly opposite. It's the real value.
Let's write the code first. Maybe then it becomes clear.
Okay, sure.
Right. So can I first of all, that's the thing. So I'll Anushka, just check your chat. I'm sending the code to you as a direct message.
Yeah, that's what I'm saying.
Okay.
We don't even need to write this code, the empty string. We can just call the previous function.
Sorry?
We don't need to write, we create T as an empty string and then for X and S, we can just call the previous function.
Did you understand?
Now I got it.
Okay.
So it was the smaller thing to do. Like we as programmers, we should offload as much working as we can on the computer. As long as we are not making it, cry. We are not making it take more and more cycles and do nothing ourselves. Like I remember that Fibonacci sequence that it nearly broke my computer with those recursions. Okay, indented.
I don't understand this thing with Python. Like, what's the difference in spaces and tabs?
In some IDEs, you have to be consistent. If you have used tabs for indent, then you have to use tab everywhere. And if you have used 4 spaces instead of a tab, then you have to use 4 spaces everywhere instead of a tab. And if you do a tab instead of the 4 spaces, the IDE will take it as an error.
Right. But why so? I mean, like, aren't they supposed to be the same thing?
That is why I use PyCharm. It does not give me this headache.
So I can use this for testing it, no? D will remain the same.
Yes.
Yeah, D will remain the same.
Then what you do is, okay, so just where you have written the final thing, just come to that, where you're calling the functions. No, the place where you're calling the functions. where you actually tested the algorithm. I think it went. Yeah. So after print substitution and encrypt SD, just write print substitution decrypt.
Same as B.
And pass whatever the encryption was in it.
Yeah,
and give it the same dictionary. Yeah.
Same SD
but this is, and then give it comma D. Yes.
Okay, sorry.
Because that was just a string, right? We have to give it the key again.
Right.
It was right.
Yeah, it works.
Got it? So how we are done with how many functions now? 4. Done with 4 functions.
Yeah, just one thing. If you have 2 minutes, I just for some reason my idea reloaded and I had to write the code again. And it's not working, but I just share my screen for 2 minutes. It's the first code. I don't know what's wrong with it, but for some reason it's just not working.
It happens all the time.
मेरी वीडियो ऑन है.
Can you see it? Can you see my screen?
Yeah.
This code. It's not removing the punctuation.
It's not removing the punctuation.
I've even put if is alpha, but even after that, it's not removing the punctuation. So it's not removing the spaces.
What it is not removing?
It's not removing the punctuation, the spaces, and the underscores.
Try putting brackets after is alpha.
Yeah, the brackets.
Okay, so yeah. And Atharva, there is one thing that I would like to point out. You don't necessarily have to use the range function every time.
Right.
You've had previous experience with some kind of a language like C or C++, I think.
Yeah.
Right. So there we were in a habit of declaring a counter, and the counter was the only thing that could be incremented or decremented in a for loops or in if loop, right? But here it is not so. Python is very lenient in this sort that if you say for I in S, then it would automatically.
That's what I had written. Originally, that's what I had written, but it was just giving me this annoying error and it wasn't working. So I just tried everything. I tried to make it as simple as possible. So I had actually written it.
And try using very obvious names. Just like you talk in English, just you use those names as variables. For alphabet in string, do whatever you want to do this, because that way your mind will never forget what you're trying to do and you'll never make a mistake in the code.
Right. Thanks. That makes sense.
I mean, it takes like a couple more seconds to type the bigger word, but then it helps you to not forget.
Yeah.
So we are done with substitution decrypt, and now we have to start with the cryptanalyze things. So we are now left with the tougher ones. Should we skip and see which of the ones can be written easily?
We're going to need cryptanalyze for the next ones.
Yeah, and I think this would be the easy one.
Yeah, this is the easiest one of them. Like, it's not the easiest one, but it's required to solve the next ones.
Yeah.
It says cryptanalyze substitution.
Because vision array is basically dependent on cryptanalyze, right? If you pass the length, if you pass the length of the password and the encrypted text, we are going to at the end need to apply cryptanalyze to find the answer.
Just one thing, can we take a break?
Yeah, sure. Sure.
Even I am hungry.
Should we come back at 9:30?
Yeah, because we cannot actually turn the stream off. I don't think that's possible because Sir was the host and this is supposed to be live. So some of us should remain and the rest of us can go. Is that the thing that we should do?
I don't mind staying.
I don't mind staying.
We can like figure out in the meantime how that what is that? The sorting
collision?
The shifting thing is working. We can do that in the free time.
Sure.
Sir said that like you can look it up afterwards, but still we are free, so we can look that up right now.
Which one are you talking about? And I didn't get you.
The collision ratio. The last one.
No, not the collision ratio. He was talking about, I think, that encrypt thing.
Yeah, in the
thing that was creating a problem. That sir said that you should write a code that does not use this encode UTF-8.
Oh, okay, the thing that you were suggesting, Hardik.
Sorry?
The thing that you were suggesting, actually my internet connection is breaking.
I suggested a couple things tonight, so I don't know what you're referring to.
I just didn't get what Ishan said. That's it. And even after what you spoke, there was that were breaking. Can you just repeat what you were saying?
So Ishan, can you repeat your question?
So I was saying, like, in one of the Cipher, we were shifting the Cipher text by S+1 now. So we were creating a counter collision ratio. So sir said, like, you can look that up afterwards. How is that working? We can do that right now in the free time.
Oh, okay, the 3.8 wala ratio.
Yeah.
Okay. Let's not look it up. Let's just I'll just say let's
work it out.
Program and let us see it work first, and then we'll move on. पहले तसल्ली तो कर ले कि काम करता है या नहीं.
Sir said, "No, it will all work." Like anyways.
Let's
it will work, but I'll say let's give it 2-3 days. Let's think over it. Maybe kuch chamkega.
Okay, no worries.
Okay, so sir had sent something. Did sir say something on Zoom or wasn't telling?
Sir said not to take a break.
Did sir say it?
Yeah, some of you can remain, and he said
yeah, that is what I said, that it's a live discussion, so we cannot everyone go off at the same time. We have to take turns of going off. So what we can do is let's couple of people stay here. We'll continue coding, right? And when the others come back, we'll explain them whatever we have done, and then we'll go and take a break.
Sir mentioned, like, let the BB group take over for the time being until we come back.
But this is not the BB group, right?
Yeah. No, let them invite them and take them over.
But then again, the problem will be like we can't tell them to leave, right? After we come back, we can't tell them to leave.
Okay, who really needs a break at this moment? Not wants, but really needs a break.
I really need one.
Okay, then you can take off. Not a problem. When you come back, we'll explain it to you from the bottom. Not a problem.
Yeah, sure.
You'll be treated like an interrupt. No problem. You don't know what an interrupt is? I didn't mean it in a discerning way. An interrupt is usually what we call as, like, if you're running a program and the device has some problem, it tells you, hey, first I have a problem, listen to me. And the program suspends whatever it was doing, it attends the interrupt, it solves its problem, and then comes back and does the rest of the work. So that is called an interrupt. That's what I was saying, that when you come back, we'll serve you first and then resume what we would do.
Just out of context, Hardik, what's your background?
I'm currently pursuing my master's in electronics, and apart from that, in real life, like absolutely, the master's is in real life also, but professionally, I'm an embedded systems developer.
Oh, okay.
Yeah.
Sorry to interrupt, but sir just messaged on Telegram that we can take breaks only. The sir said that we can ensure that you don't give a break. You can take turns and stay on Zoom because it's live on YouTube.
Exactly, that are we doing.
Yeah. So we can take turns, and then some of us can continue here, and then we can go, and the other person can do, maybe can code the same thing. Yeah.
Sorry, I didn't catch you. I was replying to sir.
He's saying that sir said that we can take a break in turns, and also, like,
yeah, I read the message on Telegram. That is what I missed it. Okay, so Srijita is gone, right? Anyone else who needs a break? All right, cool. Then we'll continue writing the other portions of the code.
Oh yeah, I almost forgot. And your BTech is in?
No, I don't have a BTech. I did a
So-
BSc in electronics, BSc
Right.
honors in electronics, and now
Right,
I'm doing an MSc electronics.
Nice. From?
DU,
Nice.
Department of Electronics here. So yeah, since this is live, let's not,
Sorry. Oh yeah, I didn't.
let's
I
not
just-
like, or turn upside down the entire bio data
Sorry.
of a person. you could chat to me on DM on Telegram anytime.
Yeah. I was curious.
So let's
You
let's
need
go.
to seem to know your way around. So.
Let's go with the cryptanalyze substitution. Anyone who wants to give it a try? I'm not willing to make mistakes live.
So we'll have to have all the frequencies of alphabets somewhere, right? For this, all
Yeah.
the probabilities of.
We can store it as a dictionary.
Yeah, I guess we'll have to.
Predict the key of the dictionary.
Yeah, you can create a dictionary inside it, can store it as a dictionary, and then match it up.
Okay,
Create
this one
another
will take
dictionary.
some time to even understand. It says that we are given a string, and it's known to us that it has been encrypted using some sort of a substitution cipher. And by this, we should, I think we should correctly assume that some sort of a Caesar cipher, right? So what the key of Caesar cipher is, we do not know, but it is encrypted using some sort of substitution cipher. We have to predict the key of the dictionary.
So we can find that difference for each element. Like even if we find that for the
Yes.
first two letters,
we have to find out. We have to find out whether it was substituted by 1 or 2 or 3 or 4, whatever, how many
Basically,
elements.
we have to find the frequency. The max frequency will be E, and I don't think we need to look even past that. The moment we find E, we just find the difference between what E is substituted by and E, and that will be our difference. That will be our Caesar cipher difference.
Yeah. So what I think is, we for our own reference, I don't know how this thing is going to work tomorrow in the hackathon, but today, for our reference at least, we can create a dictionary. We can use Wikipedia to refer for those the frequency distribution that we had, and we can create a dictionary for that, for all elements.
Do we need to?
No,
All
sorry
the
to
elements?
interrupt, but sir said we have to use the same text. We already have the second function, which is returning a dictionary, which counts how many times each letter is occurring. And the second function, we can use it by dividing. Actually, we already have the second function. Please refer to the second function that we wrote.
Yeah.
We already have that function which returns a dictionary, and that tells how many times a letter is occurring.
Yeah, that's true. That basically he's saying that we already have the dictionary which provides us with the frequency.
We have the function that provides us with the letter distribution. But what I was trying to say is we have to refer to that letter distribution to some reference. No.
We don't need that here. Why do
We can
we
just
need that
find
here?
the highest frequency one. The moment we find the highest frequency symbol occurring, whatever it be, maybe that's E. We just declare it to be E.
That letter distribution can be used to find which is the highest occurring word in that text. That sir said, and sir said that it will be in congruence with the one we found on Wikipedia.
Understood. Yep.
Yeah. So what we can do? Yeah, carry on.
No,
I think what we can do.
Sorry.
That's a good catch. Good catch.
What we can do is we can use the dictionary, and we can for each value we divide that whatever is the value, we divide it by the total letter count of our file, and that will probably give us the probability of that particular.
I'm just thinking ahead of that. I'm thinking that let us say I have an encrypted text, okay, and I start counting, like let's say it's X, T, Z, M, etc. Every time I encounter a new letter, I add it to my created dictionary. I just say, okay, at the end of the day, I have X goes to 200 times, Y goes to some n times. All I have to do is in this created dictionary, what I have created, I have to find the highest number. It doesn't matter what I do. All I have to do is find the highest number, and that highest number, the letter it corresponds to, that will have to be my E. I don't need my ratio.
Yeah, that is true. But won't you think that would be much easier if we already know for that particular text that we have encrypted?
That's true. But that won't be applicable for every text, right? That won't be applicable for every possible text.
Yeah, but for that text also we can use the same function, no? I think so.
So we are creating a dictionary with the frequency. So why not use that only?
Because that's what not encrypted. This one is encrypted.
But encrypted or not. For example, if I'm replacing A with some encrypted word, for example, let's say D. So the frequency of A will be equal to frequency of D, right? And I'll get the same ratio after dividing it by the length of string.
Yeah. If we think of it like that, remember what input we gave to the second function. We gave a non-encrypted text, and we gave a non-encrypted text. And the thing is that if we already have the non-encrypted text, then there's no reason to decrypt it, right? So that means we would have to have both the encrypted and the non-encrypted. And are you understanding what I'm saying? We don't have
that is the extreme case, but should we consider it here? It is left to our discretion.
See, we are all encrypting our text every time. This is the task what we are doing. We are encrypting, and we are also making a key to decrypt it.
I think we are creating you are creating a real life situation here. So do we need to consider it here?
Can we just match the frequencies and pick?
That's what I'm saying. You don't even need to match the frequency. You just need to find the highest frequency, and that is my E.
Yeah, we can do the top three as well, like E, T, and A.
Yeah, once I find E, then the rest will obviously match because I found the difference, and I reverted everything back to a Caesar cipher.
Yeah.
I found my key. I found my encrypted text. Just push it into a Caesar cipher. Then I can call my Caesar cipher function.
So you are suggesting we should find the highest frequency and compare it to T.
That is my E. I don't need to compare it.
E for elephant.
And accordingly, we'll know what key is E referring to, and accordingly, we can.
Yeah. All I'm saying is your method is also correct. I was thinking in that way as well.
There could be exceptions in that case.
Obviously, there could be exceptions, but we are assuming our sample text is big enough that we will always get the highest.
We can't always assume that somebody says happy birthday in their encrypted text. So there is no E in that. So what will we do?
We won't be able to encrypt it in any way. No matter what we try, we won't be able to encrypt it.
We can encrypt it by Caesar cipher.
Decrypted. Sorry. So we cannot decrypt it in any way. If just someone says just happy birthday, and it's Caesar cipher encrypted, we can try to brute force it, but that's the only way of doing it. We cannot try.
So what I was suggesting is we are happy birthday. We are encrypting it. Before that, we are creating a dictionary which has the frequency of words. We have a dictionary which has how many times H is appeared, how many times A has appeared.
Let me just clarify one thing. This dictionary that we're creating, which has all the letter frequencies, that is applicable only when my sample set is very big, right? Understand? Sherlock.
Even for the small sample space, we can just check the highest frequency word and corresponding.
We don't know what that is. In happy birthday, P comes 2 times, and that does not satisfy
but
my
I get what
table.
Srijita is saying. So she's saying, I get it what Srijita is. Sorry.
Can I explain?
So she's saying like in the encrypted text of happy birthday, we will get what is the highest frequency. And from the non-encrypted text or dictionary we will also get the highest frequency from there as well. We will compare it, we will get the key, and we will decipher it.
But if we already have the non-encrypted text and the non-encrypted text, why do we need to use this whole system to decrypt my text?
I think that case we don't have to consider here.
Yeah, because we don't know the text is encrypt or decrypt. Our task is to decrypt it, find it whether we have to decrypt
I think we
it.
can assume that already the text is given to us and we are just writing the functions. I think
guess,
that would be a real life situation that you are referring to.
Yeah, what all that I'm trying to say is that this variation, this E is the most frequent letter, T comes below that. That is applicable only when our sample set is big, and we have to make an assumption that our sample set is big, because unless we do that, we cannot solve this question.
I think we
Yeah,
can make an
I
assumption
think
here.
we can think about the happy birthday when the sample space is so low, like the password thing.
Yeah,
Right?
yeah, it's not.
We'll calculate the collision ratio and then we'll see what's the length of the word is.
I think in the book also it was mentioned that this frequency method will only work when our sample text is very large.
Yeah,
it was.
Because
It was.
Yeah, because in small
given
text,
it's a natural occurring of the language, not if it's a book of tongue twisters.
Yeah.
Because then the frequency distribution would change. So
yes,
we have to assume that it's a normal text, and whatever we like, the text that we are giving to them has to be encrypted or decrypted. So I suppose
probability
sample text. That is the point that I'm trying to make. What should we do?
Yeah, that's the thing.
We shall use our own the dictionary which we have found.
I think that would be better option. That would be better option.
But at the end of the day, do we need the dictionary? We don't. The dictionary will provide us a multiple values, but do we need, if we find what the topmost value is and all of the rest of them follow the same pattern, do we need the rest of them?
Again, Athava, I just want to make sure you are making these cases so like we are not sure whether our text is encrypted or decrypted. No.
I didn't understand your question.
So we are discussing over here because we don't know, like the text we are getting is encrypted, fully encrypted.
Yeah, it is. It is encrypted. I don't know the key.
Okay.
It is encrypted and I don't know the key. What I want to do is, what I do know is that if my text is big enough and it's English, proper English, then the most frequent letter would be E. That's what I know. And I'm assuming that my text is big enough.
This thing that you're telling, please repeat again, that I know that E will be the most frequent letter. So I am saying we can support this argument by providing us a dictionary in which E will be the most frequent letter. You're saying
but
you're
we
assuming.
Already know that. We already know that.
You're assuming now.
But
maybe in that
that's
text,
a fact in the English language, right?
No, it is not always true.
Yeah, it is not always true. That's why I put up an example of happy birthday. I can create a big text which will contain less E words and it would be a bigger sample space.
Yeah,
I can purposely create it. I can for my intelligence purpose. Suppose
that's the point. You're purposely creating it. When you write naturally, E would always come to be the most frequent, and we are assuming that this is natural text.
Okay, so we encrypt message to send it to our friends so that the enemy won't ponder with it, right?
Right.
So I know the fact, my enemy knows the facts, and I also know the fact that E would be the most highest occurring letter. So I will avoid using it. So my enemy won't be able to decrypt it.
That's the point, right? That's the point. You are creating a new system, or you are creating a new code for you're trying to work around the problem. But
my point is, I'm still using Caesar cipher, so it should be easy to decrypt it.
I get what you're saying, but
that kind of becomes a cipher in its own. Like
try
to do it intentionally, it's not Caesar cipher. Right?
Yeah, we are assuming that here we are using a Caesar cipher. That is, a Caesar cipher has been used to, like we are making multiple assumptions here. One, that it's a Caesar cipher. Two, that our text is natural and big enough to give us the representation that E comes highest and below that is T. And the third is that we are using natural language. Like it's not forcefully written in some like as Hardik said, it's not tongue twisters. Am I making sense? I'll write the code for this one and I'll come back and I'll tell you what I mean. If you think
that's what I'm doing right now. I'm trying to write a code for it.
Share your screen and write it.
Because I'm simultaneously eating something.
No, Atharva.
Yeah, sure. I'll share my screen. Yeah, 1 minute. Right, can you see it?
Yeah.
Yeah, so I can't interact with it. One minute.
Hi guys, sorry I took a lot of time.
No, it's okay. We're discussing the
Okay, where did we
cryptanalyze.
reach?
We're doing the cryptanalyze problem.
So 5th, 6th, which?
Not sure. 1 minute.
5th, cryptanalyze substitution.
Yeah.
Yeah, 5th one.
So like, are we stuck or something?
No, I was like, we were discussing what's the better way to do it.
Okay.
We are writing the codes independently first.
Yeah.
Whosoever has some kind of an idea, right? And then we'll come back and then we'll discuss what we've done.
That's a better approach. Actually, I left because I was lagging behind. So, like my codes weren't working, some errors, and continuously switching. I was making syntax errors, so I wrote the first two again, and then I got some college call.
You could have told us. We would have.
Yeah, we would have come back and help you again.
Yeah, but I felt like syntax errors I should not disturb, right?
It's okay. Like even I had a syntax error. It was eating my brain out. It told me that it was just brackets at the end.
Yeah, something like that with me too. Indentations.
Anyway,
so it happens to the best of us.
Yeah, I know. So all of us are like coding right now. Nobody's gone off or something.
No, I think someone Shrita, I think.
Yeah, I'm here.
Oh, okay, cool. Yeah, so
you guys have had your dinners and everything, and you guys are gonna like stay.
No, we cannot leave this meet. We have to take turns to go and take a break.
Yeah.
We have to keep this running because this is live.
Live. Oh, okay, sure.
Yeah. So I'll do one thing, Atharva. Since you are not sharing, I'll share my screen.
Oh, and, yeah, sorry. I was sharing. It was lagging. So 1 minute.
Yeah. Okay.
Yeah. No, it's lagging again. I'm sorry. It's just hanged. I can't.
Not a problem. I'll share my screen.
Yeah.
You can keep comfortably working. This one. Is my screen visible?
Yeah, it's visible.
Is it readable? That's the better question.
A bit of stress and you can read it. It's okay.
Okay, hold on.
Yeah.
Now is it readable?
Completely readable.
Because now I'll have this. Now I will be difficult coding this way. Not a problem. So far what I've done is I'm just writing a program at the bottom. I just keep calling functions, and I'm in the process of debugging while I write the entire function code. Okay. Because if I just write the entire code and then I run it and then I find out it didn't work, then it would be very difficult for me to go and search what went wrong. Okay, so what I've done is first we find out what's the original text, declare the letter distribution of that original text. I print the letter distribution, which comes out to be this. And then I print the cryptanalyze substitution, which is not giving us the desired output right now. But the output that it is giving me is, hold on, show you. So in PyCharm, yeah, I should share this with you. If I'm looking at the function calls and I want to go back to where the function was defined originally, what I can simply do is select this function and press Control plus B. Control plus B, B as in Bharat. And it will take me to wherever the function was originally defined.
Tharva, I need to ask something. So when you're talking about big text, what is the definition of big text over here? Like, what there should be some limit now.
There is no limit. It's always like it tends towards something. Like let us take the example of tossing a coin. I toss a coin once, I get a heads. I toss a coin twice, I toss it 10 times. Let us say I get 7 heads and 3 tails. I can't say that the coin is biased only on that data, right? If I toss it 100 times and I get the number of tails to be around 45 and heads to be 55, then I can say that, okay, my data is going towards something. It's tending towards 50-50. So that means my coin is most probably unbiased. If I do it 1,000 times and in that I get 450, 56 tails and the rest heads, then I can say, yeah, okay, it's pretty much balanced.
But I would like to counter you on that. Suppose two friends are playing a game and I'm the one, okay, you are the one who is familiar with statistics. I'm not. Okay. I toss a coin, say I toss a coin 2 times. Okay, say I got heads and heads. Both times I won. But you countered it, bro. How could that be? I know statistics. The probability should be 1/2. I should win 1 time. So toss it again. It won't happen. So same goes here with the text. If I send a text to someone, we won't like put it again and again just we would satisfy the statistics facts. You know.
That's the point. Like at the end of the day, it's always like there's a 50-50 chance of anything happen. But understand that once I toss a coin, the probability of heads or tails coming is half. Let us say I got heads on the first toss. I toss the coin again, I got heads again. Now understand that getting another heads is independent of the previous 2 heads. It's again the probability is half. But getting all 3 heads, the probability becomes 1/8. The chance of me getting another head consecutively keeps on dropping again and again. And you understand? The chance of me getting that probability drops again and again. But
like it never tends to 0.
It never tends to 0. It will go towards 0, but it will never become 0. Again, that's the point, right? It's always tending towards. It's never.
But that. I will not be keep tossing the coin again and again just to satisfy you win. We have to consider the real life situation now. So even if 5 times I won, I won't be tossing it again 5 times so that it could satisfy the probability. Again, probability is like it could happen and it could not.
Happen. Right. But understand that the probability of, let us say you won 5 times, the probability of you winning 5 times again is very low. It becomes like half into half into half raised to the half raised to power 10. You win every single time becomes half raised to power 10. The last.
Yeah, that is true. Yeah. But again, we have some limitations now. I said the fairness would be I would be tossing the coin 5 times only. Whoever won.
Yeah, sure.
So same goes with the text. It's my what do you say, wish I would write a big text or a small text, but you should be able to decrypt it given that it's a Caesar cipher.
Okay. That's the point. Let us say I have a text of 7 letters. Let us say I have happy birthday. Okay, happy birthday, and I encrypt this using a Caesar cipher by 1. So my happy birthday becomes HPP. This is
so I have prepared also a big text with 28 words, and I don't know whether it will follow it. It should not, I guess. But it's a really good message and a really natural message.
Okay.
So we can test it on that, your method.
Sure. Well, what I'm saying is, let us say if I just say happy, my message is happy, and I use a shift of 1. I can say IBQQZ is my encrypted version, right?
Yeah.
And what the point is that this encrypted version does not. The most frequent letter here is Q. And below this come I, B, and Z, which are all ranking 1. Q independently ranks. Now this in no way at all follows the natural trend, which is most frequent, right? Q is in
Correct.
quite the
Yeah, I
contrary.
got
Q
your
is the
point.
least frequent one. So the thing is that in a small sample set, you cannot say anything definitely. The probabilities of losing are too high. But when you increase the sample set increase the sample set to a level let us say 1,000 words, 10,000 words, you start to see probability exist. Like that's the Monte Carlo simulation, isn't it?
Yeah, correct. Totally agree. So see, what I want to say is in one of the above functions, we calculate the word frequency of happy. We have a dictionary which has the word frequency of happy. It's not gone anywhere.
Yes.
So I want you to draw a dictionary, let's say H1, H1, A1, P2, and Y1. This is the dictionary I have with me. So now I am decrypting the text. It has gone I, B, Q, Q, Z. Now I have the function which will create a word frequency dictionary. So I will call this function on the decrypted text. Encrypted text.
Can you please repeat that point?
Okay, I'll go.
I did.
You have encrypted the text happy.
I have encrypted happy. Okay.
Okay, it comes I, B, Q, Q, Z.
Yeah.
You told that. Now.
Yeah.
So I will now call the function again, which gives me the word frequency of
which
letter frequency.
Are you calling?
Letter frequency. I will tell you the exact name of.
Okay. Yeah, letter frequency. Okay. Yes.
Letter distribution.
Yes. Yes.
So now I will get another dictionary which says I1, B1, Q2, Z1.
Yeah.
Now what I will do is in the second dictionary, I will find the highest word with the highest frequency.
Right. That's Q.
That's Q. I will divide it by the length of what do you say? The happy or IQ, IBQZZ. That is 1, 2, 3, 4, 5. Yeah. 2 by 5, 0.4.
Yeah. Okay.
I have the ratio which we were calculating from the starting. And I will call the same method in the happy dictionary. I have it with me.
What's the happy dictionary?
The dictionary which contains the word frequency of happy.
Right.
The first dictionary which I made you create. So in that I have P with 2, P with frequency 2. I will divide it by the word length of happy, which is again 5. It comes out to be 0.4.
Here, understand. Yeah, I understand what you're saying. Here you have a sample set which you are encrypting. You are saying you don't know what method you're passing it to. You're encrypting and it's a Caesar cipher.
Yeah.
And you're getting an output. And you have both of these. You create the dictionaries, you compare them, and then you correlate what you have. That's what you're saying, right?
Correct. So it will work in the big sets also and small set. You give me any set,
it will always work. It will always work. Understood.
And it is also following the fact it is comparing the words with the highest letters with the highest frequency.
Completely makes sense. But the point is that we are trying to solve this cryptanalysis like this because we don't know what our original text was. All we have at this point is an encrypted text and the knowledge that it's a Caesar cipher.
That also makes sense. We don't know the
That's all we know at this point, and we want to solve it by that.
But I was thinking as a point of view, more of a point of view like a programmer. We have created the dictionary.
From
we
the
have
point
it
of
with
a
me.
programmer, that makes complete sense.
Okay. I think we are clear of each other's point.
Yeah, I think we're trying to say the same thing, but in like two different ways.
Manner. Yeah.
Yeah. Sure. Okay.
I think I got something. I mean, but I'm not sure. Can someone check it?
Go on.
I'm sharing my screen. Okay.
Yeah.
Hardik, I think you'll have to stop. Thank you. This is this one. So this is of no use.
So you're brute forcing it.
So I know I should not be using S here. S is
the original thing.
Just replace it by anything else.
But how do I check it then?
Create a copy.
नहीं हमें तो सिर्फ जो encrypted
She's
list है वो
also,
दे रखा है
yeah,
ना.
she's like using the happy text. We don't know the happy text. We only
right.
are given the encrypted.
right.
She's using the brute force method, right?
Yeah, like after every point you would have to like go and read the text and make sure if it makes sense.
Exhaust all possible combinations. Now imagine that the encrypted text that was given to you was not a 200-page novel, but rather it was a 1500-page dictionary.
But the thing is with Caesar ciphers, you don't have to use a lot of brute force. Even if you have a dictionary, all you have to do is take one page of the dictionary, apply Caesar cipher for all of them, like or even not one page, one sentence. Apply Caesar cipher for all possible brute force that one sentence only.
But there's
a very difficult thing to do.
There are 26 letters we have to consider.
Still, it doesn't make lot. It doesn't take a lot of effort. As long as you, at the end of one of those, you get a readable sentence. That means you found the Caesar cipher which works.
How do you translate? How do you translate readable?
Yeah. That I don't
machine's
know.
language?
That I don't know.
Either you do one thing. If you necessarily have to brute force, limit it to some number of characters. Let us say the first 50 characters.
I can do that.
Got it?
Huh.
If you want to translate the readability aspect of a human to machine's brain, then you should limit the number of characters that are being matched every time, so that it does not have to go through the entire text again and again.
See, that is okay. That I'll do. But the thing is that I'm checking it with the original text, which we won't have. What do I do instead of this?
Yeah. That's what he's saying. That you don't have the option to do that. So use an alternative. I didn't understand the alternative, but he's saying use some other alternate method.
What's the alternate method?
Yeah, could you come again, Hardik? What exactly are you saying we should do?
I'm writing a code for the same and then I'll get back to you.
Sure.
So I need to make sure that it works on my end also before I, spoil your line of thought.
So we are going with Atharv's method, right?
Like everyone's going on their own method right now. We're just saying whoever works, we'll use that.
Every method we discussed will work, but the point is how we are considering it.
Yeah. My method is heavily based on the fact that we are assuming our text is big, it's natural, and that E is the most frequent letter. If all these are satisfied, then my method will be able to crack it. If it isn't,
I think we need to confirm this with the sir, I guess. We should confirm this with the sir because we have two very good and working methods.
Still then
we can discuss it amongst ourselves because tomorrow sir might not be available with us all the time.
Yeah, we should ask him.
We should be clear on these things ourselves.
Yeah, if we are supposed to explain them to others, then we should have crystal clear.
If you don't understand it yourself, how would you explain it?
That's why we are doing this now, so we know what we are doing tomorrow.
So what you could do is write one code, run it, write the other code, run it, and then you'll see what is happening.
That's what we are doing.
I have a doubt. Guys, can someone? Hello.
Yeah.
So I am getting a key error in letter distribution function. So can someone check?
Yeah, share your screen.
You're getting a key error.
Yeah, I had got the same Ishant. Ashik, hai na?
Yeah,
Ashik, I solved it. Show the screen.
I did actually everything. But then the key error is that AE. This is also a type of word.
This is actually this is the problem with your above function. You are returning that. So you are doing it.
I also printed it. This also is printing correctly.
Ashik, you can just put one condition after, like if you go to the letter distribution, you can just put in the second for loop, if X in alpha, then only increment the value of the dictionary.
If X what?
After this, you can type if X in alpha.
Alpha. Then this condition, right?
Yeah, this one work, I think.
Guys, can I say something?
Yeah, go on.
Let's stop. Thank you.
Yeah, Ankush, you were saying something.
Yeah, we have already checked this, that condition is alpha. So why do we need to check that again?
Alpha, which one are you talking about?
The last one, which he said.
Ashik's
Distribution
doubt.
function.
Okay, sorry.
The previous function we had check is alpha, but that too, here again we have to check it. Is it Parth?
Yeah, the same one. Why do we need to check it twice?
Hello, Parth.
Ashik, share your screen once more.
Could someone tell me that if I have a letter, how do I backtrack and find its ASCII value? Or
you need to find out the ASCII value.
No, not the ASCII. I just want to know that I want to create a table where A is 1 and B is 2. Do I have to manually do that, or can I just, is there some way of doing that?
Can you show me your first function?
You want to create a dictionary of
No, why
some
I'm
manner
asking
so
the
that all
ASCII
the
value is because, like, if I say ASCII, then I know if A is some n number, then B will be n plus 1. So I can just subtract n minus 1 from that ASCII value every time and just get that.
Are you asking that?
This works in
to
C,
fit
but I'm
your
not sure if it works in Python.
Yeah, there is one called CORD method. You can just encapsulate whatever text you want to convert, but it needs to be single letter only. Then it will work.
It's a single letter.
Yeah, so you
it will
use
convert
CORD. Yeah, it will convert it into ASCII.
Nice.
Guru Raj stays silent and then comes out with the big guns.
The problem with is alpha is, I think that the is alpha also contains some values which it, like the AE value, it is considered as is alpha in is alpha part.
Yeah, I got that error too.
Yeah, also
Should
got
not
that.
use
So
that.
what I consider is alpha has A to Z, also A to Z, but it also has some unique characters in it, which it consider it as it is alpha. Are you getting my point? Like the AE text we got as the output.
Yeah.
But we
So
have
for that
printed
reason, we have to
the
check it here
alpha.
once again.
In alpha dot string, alpha is equal to हमारा string dot ASCII dot lowercase. So it only contains A to Z in lowercase. But in is alpha, we have A to Z in lowercase, A to Z in uppercase, and few characters also which we don't know. But but the program considered it as alpha. Got my point?
Okay, that's fine.
Okay.
Can someone clarify what do we have to do at this moment, like right now?
We're writing the code, we're writing the function for cryptanalyze substitution.
Okay.
Hello, just a suggestion. Can one of us share our screen while working on his or her code? Because this is going live. So
Yeah, sure, I'll do that.
Yeah, thank you.
Is it visible?
Yeah, it is. Thank you.
I think I have a code that might work. I'll test. I'll see. 1 minute. Could someone help me in making a dictionary, which is like A goes to 2, B goes to 3, C goes to 4. How do I code that?
Can someone help you out, please?
Okay. Where do you have to type it? You're not sharing your screen. Okay, start with curly braces.
Yeah, no. I'm just saying that what would be the logic? Would I create a string and then?
Do you know dictionary comprehension?
Yeah.
Okay, so just do define alpha is a string with all alphabets.
Okay.
Then dictionary comprehension के लिए curly brackets open. Alpha का accept element colon, that is it's mapped to x plus 1 for x in range length of alpha.
Right. Got it. Thank you.
Okay.
Okay, so I do have a working code right now. Do you guys want to try yourself and then I should explain, or do you want to look at it first?
Yeah. Let's give us 5 more minutes.
Sure. All right, you try it. I'll just keep it as a shared screen, just in case anyone else wants to look at it.
Yeah, sure.
Yes, I can. This. Is it visible to you, both the code and the result?
Yes.
Does anyone have a doubt with my code at least?
That looks good. And now what we can do is we can create a function which accepts this key and returns us a dictionary which maps these values to the original alphabetical values.
So what is, it is already here. I didn't actually include it there, but I used it in my test case scenario. It's written there. It's just like the dictionary comprehension that on the screen.
Yeah, I understand. Yeah.
Can you scroll up?
Sorry?
Scroll up, please. Can you explain lines 74 and 75?
The lines 74 and 75. Okay, so you probably noticed that ASCII notice it's not a function. Did you notice it? It's not a function, it's rather a standard variable that's stored in the string library. Right? So I know that this standard variable is of the string form. I also know that a string can be indexed. Right. So what I did was, if you've understood till here, whatever I found out to be the letter with the maximum frequency, I simply subtracted the index of this letter with E.
Why?
Okay, interesting. So this is why I have printed this entire thing here. So can you see this? This is first of all a key, which is for the encryption of data.
Okay.
Right. And I've used the key value to be 5 here. I could use any value.
Okay.
So I use the key value to be 5 here. I'm yet to check whether it works on the extreme values or not. Let us test and see how it works. Okay, then it says if the key is 26, then this calculated substitution key is 0. Because if I substitute it if I roll over 26 times, it would then again return to the same thing. But if I substitute by 25 times, then the substitution key comes to be -1, which again rolls over from A to Z. Does it make sense? So, okay, even if it doesn't make sense right now, let's go back to 5. This should be easier to process. This is the key for encryption, in which the key is A and F is 5 letters after A. So what happens is, this is the letter distribution of the original text. You see that the frequency of E in this case, which should be ideally the highest, is 30051.
Okay, I think I got it. So what we did was, no, go on, sorry.
No, you might have actually got it. It's not that difficult. I just did a simple reversal of things.
But see, baat wahi ho gayi. We have the encrypted string. Usse we found out the. अच्छा नहीं.
यही तो करना है. Encrypted string है, and you need to find out what was the key of substitution for this encrypted string.
हाँ, तो उससे हमने maximum frequency वाला letter निकाल लिया.
Maximum frequency वाला letter निकाला. ठीक है. Now, according to statistics, according to common statistics in English language, the letter E has the highest frequency in usage.
Oh. Okay.
Got it? Now, since letter E should be the most frequent letter to be used of all, now this function is very statistic in giving out answer. If the input text is not representing a very good sample space of the English language, then this function will not work. Right. But considering that we were given a fair piece of encryption,
that the sample space is very large,
that the sample space is good enough, we can take it to be a credible sample space, then I can say with a good confidence level that E should be the letter with highest frequency, that is 30051 in this case.
Now I got it.
Now we check what letter in the encrypted text shows up with the most frequent observation. And in our case, since this is the letter distribution of the encrypted text, I see 30051 is for J. Did you understand now?
The key should be index of J minus index of E.
Exactly. So J, so the most frequent letter in the encrypted text should be represent the most frequent letter in the decrypted text. And since ASCII.lowercase is a string of all the possible alphabets, I can simply subtract their indexes and get the difference between them. It does not matter that the list or the string starts from 0 to 25 or it goes from 1 to 26. It may even go from 26 to 26 plus 26. So the indexing of the string does not bother me. What only matters to me is what is the difference between the indexes. That is why taking the difference in this case was a sufficient exercise for me to find out what the encryption key was.
Thank you.
Anyone else?
I've written the code, but it's not working for some reason. I've got some errors. But yeah, the basic.
Hardik, can you once again go through this code, please?
All right.
Yeah,
so,
basically my code is just like Hardik's. Yeah, so.
Okay, so Hardik,
yeah, you can go on.
So let's do one thing. Let's. Is anyone trying to write the code by themselves?
Yeah, I am.
Apart from Atharva, is somebody else using some other logic or anything that they're writing to trying to write their own code?
I am also using another logic.
Okay, so let's wait for you then. You come up with your own idea, come up with your own code. Just tell us how it works and if it works. Yeah, somebody was saying something.
I'm trying out something.
Okay. Meanwhile, the code is open to anyone who is finding or using the same logic as me. They can refer to my code as well, and they can try figuring out what is happening and when and what, how do I do things in this case. I've tried to kind of label my output data very well so that you can understand what each printed statement represents, so that it will be easier for you to understand. But even so, if you don't understand, I'm here.
Hey, can someone send me the code for substitution decrypt? The earlier function.
Who was asking for the code though?
Harshit.
Okay. Harshit, are you a volunteer?
Yeah.
Okay.
I am here.
अच्छा ठीक है. Please don't just copy the code. Try to understand it and then copy the code, because if you do not understand it, we all might
I
be in trouble.
understood. Actually, I had not copied it. I was discussing here, so.
I'll need to spend some time on commenting my code now, because as we go forward, it might become difficult for everyone to. So before I send the file to you all after the session, I'll make sure I comment each and every line, or I'll try to at least comment each and every line or a block, whatever the function is performing, so that if you want to go through it yourselves, you can easily understand what it was all about.
After Harshit is done, can I just share my screen? I'm still stuck on the substitution encrypt code.
All right, sure. So Harshit, are you done?
Yeah, maybe. Okay.
All right, what I'll do is
Yeah, thanks.
And it was Mehul, right, who was asking for the substitution encrypt code?
Yeah, I got it.
Here it is.
Can I show you mine and see where it's going wrong?
Sure, yes, you can.
Yeah, we'll do it together. Share.
This might be too messed up, this line 45, but I sort of cooked up that logic while getting stuck.
Sorry, can you repeat?
This line 45 might be very messed up, but it was like I wasn't clear of the logic, so I tried to make something up while doing that, while coding.
Okay, just let me check. It says for I in range length of alphabets. Alphabet says what? String.
He's doing the same thing which you tried to do. He's like replacing the key from the dictionary in the original string only.
Yeah.
He's like doing it in the one string.
Actually, that method would not work. I also learned it the hard way. I don't know. Yeah, Ishant actually pointed it out to me that you have to see and try it like this. Let us say that we have a string that is A, B, B, C, C, D, D, right? And the key for A is Z.
Just a second. Just a second.
You can write it down. Just create a comment line and write it.
Yeah.
Just write a string A, B, B, C, C, D, D.
A, B, B, C, C, D, D.
Right, and it continues up to Z, Z.
Okay.
Right. Now let us say that the key for A is Z.
Key for A is Z.
Z. Yeah.
Okay.
And the key for B is A, like the previous element.
Okay. Okay.
Okay.
Yeah.
Now what happens is the first time you replace it, what will be the output string?
Z, Z, A, B, B, C, C.
No. In the first iteration, you should not think like a human being. Think like how the computer is doing it. It's taking iterations to do it again and again and again and again.
Yeah. I'm not sure I get what you mean.
Hold on. Just for ti equals to ti dot replace.
Should I help you?
Yeah, sure.
Yeah, sure.
So let's consider the king A, B, B, C, C. So what you are doing is in the above string, you are replacing A with D of X. So what D of X is, you know now what your dictionary is. Your dictionary is the key and value pair in which the key is the original letter of the alphabet, A, B, C, D, and the value is the cipher text.
Yeah.
Like if your A is associated with Z. So now you are replacing all the A's with the Z. All right. And all the B's with something. So, okay, wait.
See, I'll tell you where I'm having the problem. I did not go into the function till now, but this part.
Oh, yeah, I got it. See, you are converting all the A's with Z. Now, when you come to the second element, that is the second A, it is already converted to the Z. By replace method, all your A's.
Okay. Yeah.
So it will be converted from Z to something else.
Oh, okay. Okay,
Got my point?
I understood. Yeah.
So instead, you should create a new string, which is an empty string, and append the letters to it.
Converted letters, right?
Yeah.
Okay, so basically,
I'll help you. If you understand that, erase that comment. So let's create a new string in the function.
Wait, I'll just delete this one too. Okay.
Yeah, sure.
Start.
No. Keep it as it is. So we will be replacing this code only. Don't worry.
Yeah. Okay. So first I'll need that alphabet, right?
First, you need a new string, which will work as your encrypted string. String, not list. Yeah, correct. Now, for X in S, now you're iterating over the string. So what you need to do is you need to map, find the value of that key.
Yeah.
So go ahead. I'm not trying to be obvious. I want you to work this out on your own.
Cool. So for X in S means the element X in our Sherlock.txt. So
yes, we need to find that X in the dictionary. What is the value of that dictionary? We need to find the value of X in dictionary.
In the alpha dictionary.
Yes, which is provided in the function T. T is the dictionary, na?
Okay. So yeah. So and what do I need to do with it? So I find the value over here.
So you need to append it, the value. You need to append it to the T. So you go T plus T. T is equal to T plus something.
Okay. Oh. Just a second. So
take your time. The string appendage works like t is equal to t plus.
Huh. 8 seconds.
Yeah, what should be the value? It
D of x.
correct, right.
Oh, okay.
So this will convert your entire
Yeah, and
decrypted
then
string into the
I will
encryption.
return T.
Yes, correct.
Cool. Now before this, acha. So only this much is the substitution in encrypt code.
Yes.
So outside this, now I have to make my dictionary, right?
Yeah, the dictionary which you whatever you decide to be the encryption.
Yeah. So actually, I was having a trouble with that only. Didn't go to the function after that.
Yeah, we can also create
Yeah.
that.
So D is equal to empty dictionary.
Okay.
Then alpha is equal to string dot ASCII lowercase. Okay.
Fine.
For I in not wait for not yeah, for I in alpha. D of I. D of I is equal to. So
Yes.
what do I keep it as?
So what do you need? You need to put 2 values ahead, 3 values ahead, 4 values ahead. What do you want the encryption to be?
Okay. So
but this will create one error.
What?
Let's say 1 value ahead, but this will create an error. I will tell you. Just put it 1 value ahead. I'll tell you.
D of I is equal to alpha of I plus 1. Do I do? Exactly here where I'm getting confused.
It's alpha I plus 1.
This right?
Alpha is a string, so we can access it like a list.
Yeah. Alpha of I plus 1.
I plus 1. Wait.
Okay.
Let's put it so like no. This won't work. This is for I in range len of alpha kar dete hain, because we'll be using the indexes. Got my point? Why we did that?
Yeah.
So that we can easily access the index.
Yeah, नहीं तो वो alphabet plus number हो जाएगा.
Correct. But here you have D of I won't work. D of I will represent a number now.
Number, yeah.
So you have to do D of alpha of I. Make sense?
Oh, yeah. Acha, okay. Is equal to alpha of I plus 1.
Correct. But now when the D of alpha of I reaches the Z part, it will create a index
the mod
error.
26 thing. Okay, yes.
That's why we'll do mod 26.
Yeah, not mod this now. 26.
%26. We'll take the remainder.
I saw the double slash in somebody's code. Okay. Okay.
I guess it's fine. Everyone, can you just confirm it? Anyone?
Let's print D and C now.
Yeah, let's try printing it.
A is B is perfect.
Now try passing in the substitution encrypt.
Okay. So now
no, first you need to call the letter first function, which will give you a string.
Yeah, so Sherlock.txt is not a string, right. Sorry. Text strip of Sherlock.txt.
You need to store
function.
No, I can do this too, right? Text strip of Sherlock.txt. I'm just trying different syntax.
Yes.
Comma 1. No, not 1. D.
Just check the brackets. I think you have messed up with the brackets. Because I think D will come right side.
Oh shit, yeah.
That's why we don't prefer like doing it between.
Yeah, I get it. To open, to close. गलत है. एक second.
Check the position of D. Substitution. Yeah, the position of D is correct. And we have the brackets as well. Okay.
Yeah, it's correct. Yeah.
D is equal to T plus Tx.
S of x, no? No, D of x won't work inside.
Just a second. We have our D for x in S.
S.
No. Should work.
Wait.
Why it's not
Wait,
working?
what are we doing here? Empty string, and for x in S. Okay, we have to take D also. No? So do we just call D here?
No, we have the
Can't
D
do
as D. Just x in S. So we are iterating over x
in S. It should be D only.
D plus Dx. Dx is now string which should contain.
Mehul, I
could
think
just
it will. Can I speak?
Yeah.
I think it's the same error that Shubham or someone else was getting, that A thing, right?
Yeah, I got that same error. So that I was saying that you could call the function before this one. Substitute encrypting.
Yeah, you should try calling it
Instead of
before. No, it's right. It's right. Copy text script Sherlock wala part.
And I'll call this outside.
Yeah, call it outside and store it in a variable.
Okay, I get it.
You copied the wrong.
ठीक है. A is equal to text strip of Sherlock dot txt, and then substitution encrypt.
See here what happens. You are copying the whole text, right? We want that a text which is only of alphabets, that to lowercase, and your A is complete text. Getting?
Okay. Yeah.
So we have to you call that function which is returning you only the text which is required for all the questions, rather
fine.
Lower case alphabets.
Acha.
Yeah.
Okay. I got it. So now this should work. No, it isn't working.
Okay,
no, that is what
we are getting the key error wala. It's from is alpha. Have you used is alpha somewhere? Can you show it to me?
See, this is the text strip code.
In the 12th line, you have used is alpha. Instead of is alpha, can you compare it to the ASCII underscore letters?
Word.
Create a variable called alpha under the s.lower.
Guys, I'm taking a 5-minute break. I'll be back. I have a small task to do.
Assign it to the A to Z,
right?
Lowercase.
And if you guys wind up with this function, you can start discussing the cryptanalysis, wala. And when I come back, I'll share my solution with all of you.
Yeah.
Cool.
Yeah, try it now.
I'll check the indentation. Okay.
Okay.
Yeah, I guess this is the encrypted text. Yeah, BZUF, I guess so.
Okay, I think my computer just froze.
No, it's not frozen. This is what is the output is encrypted
I'm
text.
trying to scroll it up, but it's going very
Oh.
yeah. BOJ. So first one was content. I know that much. C became B. O remained O. Is that what happened? Mm-hmm. Okay. DHIEF, yeah, perfect. Works. Okay. Now what would be the next one? I understood this. Thanks. It was Ishant, right?
Yes.
Yeah, thanks, Ishant.
No worries. Is that over here?
Yeah.
Like, is he gone for the dinner or is present?
Who? Hardik?
Atharva.
I don't know about Atharva. Ishant, so have you finished this one also, substitution decrypt?
No, I was looking at Hardik's code. I'll complete it right now. Wait.
So what is the basic idea? What do we have to do? We have to take a decrypted text. No, we have to take an encrypted text, right? And then we have to decrypt it.
Yes. So what we saw on Wikipedia, we know that E is the most frequently occurring letter in the English text.
Okay.
So on the basis of that, in our decrypted text, we will look for the most frequently occurred letter. For example, in your case,
Wait.
be.
So basically, let's discuss the pseudocode directly.
Yeah.
What will we do is just a second. Just tell me if I'm wrong.
Yeah. Okay.
This function, the letter distribution function for S once we'll run, and then for different letter distribution for Sherlock, and then letter distribution for this S string.
Yeah, encrypted text are.
Yeah, encrypted text. And so encrypted दोनों का letter distribution आ गया. So now we know the decrypt in encrypted text wala E.
No.
Should I explain?
Yeah,
yeah, go ahead.
So see, you are a person and I am a person. I will give you the mappings of the each letter alphabet. Okay. So
Yeah.
if A is mapped to B, B is mapped to C. Like this, all the letters are mapped in a dictionary. Now in substitution decrypt, that is name, right? Substitution decrypt. What we need to do is we need to reverse that mapping. Okay. So we need to make D A, B A, and like this for every element we have to reverse that.
Yeah.
Because original text is encoded according to like in original text A is encoded to B, right?
Yeah.
So to decrypt it, we will need to map B to A.
So basically, the information which we have is the encrypted text and the key with which it was encrypted.
Yes.
So basically, we just have to for every element in the encrypted text, go back key spaces.
We have to like kind of reverse engineer the
First one, encryption
encryption.
one.
Like,
Okay.
yeah, if A is mapped to B, I need to make a dictionary in which B is mapped to A.
Okay. Okay.
Yeah.
Cool.
And
I'll try it now.
okay. Oh, maybe try writing it on a like a register or something. You'll understand it.
Yeah.
Did anyone else start the cryptanalyzer?
Can you repeat?
Did anyone else start the cryptanalyzer?
Yeah, we are just doing.
We guys just like you guys while doing it finish the cryptanalyze function, right? The cryptanalyze substitution.
Okay, can you repeat?
Like you guys were doing on the session throughout, right? So you guys have finished discussing cryptanalyze substitution, right?
We have not finished discussing. We discussed like the Hardik coded it, and he like we will discuss it again like after he comes back.
Okay, so like not everybody has written it.
I don't know about that, but we will discuss it again after he comes back. That I know.
Okay, cool. So, अच्छा ठीक है.
Hey guys, sorry to interrupt. I just wanted to ask, we can collaborate on Replit now?
Yes, I think also.
So if I want someone to send me the encrypted text on Replit, someone can copy paste it on my code. I want to test the function, which is this one, cryptanalyze substitution. I had written a code. I wanted to see if it would work or not.
So you want us to one of us to send an encrypted text to you?
Yeah.
Oh, for that we'll need to convert it into TXT, right?
No. If someone else is also working on Replit, they can share. They can copy paste their code there, and I can copy paste it to my code.
Yeah, I'm working on Replit, so you can join me, but I don't know how to do that.
What is your username on Replit?
Mehulman2905. Capital M's. I'll just paste it in the chat box.
Okay.
That.
Mehul, are you there?
Yeah, Harshit, tell me.
Yeah, you received the message?
Oh shit, yeah, I just received it. Sorry, I didn't check it.
Yeah.
Yeah, so Harshit, what code do you want me to paste here?
I think you are done with encrypting the text.
Okay.
Okay, so I'm creating a variable B. You can copy your code, whatever dictionary that you have used
C.
to encrypt.
Is this fine?
Let me
Actually,
see.
you know what? Wait.
Mehul, could you just fill me in? I was gone for 2 minutes.
Yeah, just a second. Harshit, check if this works.
Okay.
Yes, Atharva, tell me.
Yeah, I was there when we were solving the
Cryptanalyze.
Yeah, cryptanalyze.
Yeah,
So after
उसके
that,
आगे कुछ नहीं हुआ. Hardik has gone out for 5 minutes.
Okay.
He'll come back and then we'll discuss it again maybe.
Okay, sure.
I'm still on the decryption code.
Okay.
Just the one before this one.
Okay.
Guys, even I'll just be back in 10-15 minutes. Please, can somebody explain me the cryptanalyze thing if it's done before I come back?
No
Before you
problem.
come, before you come back or
After.
after?
Sorry, yeah, after. Sorry,
Yeah,
I'm
sure.
actually getting a bit short-circuited today.
It's okay. It's okay. Yeah, sure.
Thanks.
It's been too long.
Yeah.
It's actually been too long, and plus this thing. I don't know. I'm getting scared to code now. I don't know. It's just too intimidating.
It's fine, we'll help you.
Yeah,
as
look.
much as we can.
The main thing is, right, be modular. That happens to me a lot. I try to code really continuously, and then I am not able to make a lot of mistakes. Errors keep coming, and debugging doesn't work, and then I get frustrated, and that happens a lot. Don't let that get you. Firstly, always be modular with your code. Every line you write, firstly, make sure the variables make sense. Secondly, make sure you have a comment for that line. And thirdly, make sure it's modular. Check after every single line. Try to use a print statement. Try to use something. Make sure your code works till then. And after your code works, just write a note for yourself that, okay, code works till this line. Something like that. Break your code into pieces. Modularity helps a lot.
Yeah,
Don't
that actually sounds
don't
like a
get
good idea.
frustrated.
I've written like around.
Sometimes,
Yeah, tell me, Shishita.
sometimes you just make some silly mistakes. You just forget a bracket here and there, and there's
Yeah.
yeah.
And then what happens is it gets really frustrating when you can't debug it. So don't let that get you. Just be modular. Have a modular approach so that you can say, okay, 1, 2, and 3 work. 4 doesn't work. 5 works. So the problem is in 4. So then you can just play around here and there, and at least try to figure out. At least you've pinpointed where the problem is.
Right. Yeah, I think I should do that because in 60 lines I have 0 comments.
Use that.
Yeah.
At least 3-4 lines. Write a comment. Okay, this works, or what am I doing here? It helps a lot.
Okay.
And again, Hardik said that use variables which make sense to you. Like don't just say for every I in this, for what is I and what is like S. Try to be a bit more elaborate, because when you are like writing the code, it's not a big deal. But when you're debugging the code, it helps a lot.
Okay. I'll be sure to try that.
Okay.
Thanks, man.
Sure.
I'll just be back, guys.
Okay.
Atharva, you on that cryptanalysis one?
Yeah, I'm writing that. I'm actually I don't know, there's some error. It's like backtracking into multiple different codes. So I'm trying to debug that.
Oh, okay. I actually implemented yours and it's okay.
Does it work?
Yeah, yeah.
Okay, great.
I liked your method.
What?
I like that. I like the idea behind your method.
I mean, like, it makes sense, right? You don't have to check everything if you can check the top number. Can I share my screen? I'm getting some error, but I can't even understand the error.
Yeah, sure.
Can you see it?
DFX. Where are you getting the error?
Yeah, the error is in this block of code. The previous block is checked and the lower block is commented out. So the error is here, but I don't understand what the error is, because like it's
Oh, I
showing
know what that error is. Go to the above function above it.
this.
The above it, like yeah, where you clean the file. Yeah. So if is alpha also you see that key error, that A.
Yeah.
So is alpha includes that too. So that still
You
remains in your
just
text.
change it to
Yeah.
just add that alpha equals to ASCII underscore ASCII string dot ASCII underscore lowercase, and then you find it in alpha.
Sorry. Can you repeat? I don't understand. What are you saying?
Wait, I'm just telling you.
Where should I?
You just do it alpha equals to string.
Where alpha? Okay. No.
Just
Where?
below where you wrote s equals
Yeah.
to.
Here alpha
You
equal
write
to string. Yeah.
String dot ASCII underscore lowercase.
Yeah.
You take all the lowercase letters, and then then you find the s element inside alpha, like si in alpha.
If x in go to the second for loop.
Yeah.
Go to the second for.
Yeah. Here.
Second for loop.
Yeah. Okay.
After
X
for
in
x
alpha.
in s.
Yeah.
You can type if x in alpha, then append the dictionary.
Okay. Great. Got it. Thanks. Okay. Good. Great. Thanks.
No problem.
Tell me, what are we doing right now?
We were actually just trying to write the code for cryptanalysis, and Hardik was going to explain his code, but he's gone for a 5-minute break, and I'm trying to debug my code.
Okay.
I think Parth wrote the code, it works. So yeah, that's where we are right now.
Okay.
We need to remember things like this, that a whatever that symbol was that shows up. So like tomorrow when the codathon hackathon will be taking place, we need to like make sure that people don't make the same mistake, or at least we are able to explain this to them.
There would be some mistakes which vary from a PC to PC too. So
Yeah.
we might have to troubleshoot that too.
Yeah.
Hello.
Hi. Who's there?
Yeah, Harshit.
Okay. Yeah, sure.
Yeah, I needed some help in the definition function substitution encrypt.
Sure,
yeah.
go ahead.
Yeah, can I share my screen? I'm getting an error there.
Go on.
It says key error, and then
Yeah. Okay. I just had that error right now. Share your screen.
okay. Is it visible?
It's black. Yeah, it's visible.
Yeah, this error I'm getting. In line number 41.
Here D.
Yeah, this is new. Here
Yeah, this is new.
I don't know where I'm going wrong.
Can you scroll up a bit? Can you show us the other functions? A, B, C, D. Mention D over there. T is equal to dictionary.
Do one thing, comment everything below this out. So we can just focus on that. Use double commas and comment everything out.
Okay, I think. But
And
I
then
think
try.
this is when I'm using this substitution encrypt inside this function, cryptanalyze substitution, then it is showing the error. If I'm using this function
Independently, it's not.
Yeah, independently, it is not showing an error. I think let me try it myself once more.
Okay, yeah. Try that.
Anything happen in between?
Since
in the last 2 minutes or 3 minutes?
No.
Hi guys, welcome to my new YouTube channel. क्या चल रहा है? क्या कहाँ तक पहुँचे?
और वही के वही है.
Please ऐसे मत बोलो यार. कहाँ पे?
Cryptanalysis. My code is spitting out errors like crazy.
Okay, let's identify कि पहले हम लोगों की strategies same है या नहीं. What's your strategy? Lay it out.
मेरा basically cryptanalysis का मेरा तो फंडा यही है कि हिंदी चलेगा ना? Like, or do I have to stick to English?
सब चलेगा.
So basically what I'm trying to do is create a dictionary for all letters. I don't care what the letters are. I see a new symbol, I'm going to put it in the dictionary. The moment I see it again, I'm going to add one to it, counter badanga, and I'm going to find the most frequent symbol of them all. And the moment I find that symbol, that will be my E. That must be my E. And then I'll find its ASCII value. If I know the ASCII value of E, I'll subtract that. That difference is my cipher. That difference is my shift. And that I will add to my original dictionary, and I will get my as in ABCD. I will add that to ABCD and get my new script.
Okay, so logic sound है सबका. Who has been like सबको मिला के who has been facing the most difficulty जिसको अभी तक logic भी clear नहीं हुआ?
guys feel free to say like yes problems forward, because like हमें बाद में सिखाना है, and like if you don't
because हम
understand,
लोगों को बाद exactly. So we need to be clear on this.
like logic clear होना चाहिए.
We cannot proceed to the next function without understanding this.
Yes.
No, it's not even like कि तुम next function लिख लोगे इसके बिना इसको use करके. Unless you understand this, you won't be able to understand the next.
So like feel free कि नहीं समझा तो नहीं
so
समझा.
अगर एक और बार explanation हो जाए तो better है.
Okay. Should I or Hardik?
So Atharva, do one thing. Okay, I'll do this. I'll share my screen. Okay, I've painted a very beautiful picture. I've labeled my outputs as well.
Great.
So everyone will be able to see कि हम किस direction में सोच रहे हैं. In what direction are we thinking first of all?
Okay.
Right. Then everyone can take a look at what the code is. I'll explain it. I'll explain it line by line.
Okay.
And then you can try to write that code yourselves. And for all those who have understood what my code is, and they're meanwhile, and in the duration that they're writing the same code themselves, we'll sort out your problem.
My problem. My code problem, right? Yeah. Okay.
Of course, great. Your code's problem. I don't know what your problem is. So I'll share my screen.
Yash. Yash, are you from the volunteers? Are you from the volunteers? Yes. Oh, okay. So basically, what we are doing right now is just mainly for the volunteers. What we are doing is, you know what we are doing? Do you know like what we're doing? We're just trying to basically. Okay. So, are you frequently in the lectures? Yeah. So basically, for tomorrow's hackathon, we are going to we are the volunteers, and what we are trying to do is write the code so we thoroughly understand the logic and we are able to explain it to the people who are going to write the hackathon. So if you're not a volunteer, no need to attend right now's lecture meeting. You can come tomorrow. The form will be circulated. So yeah, we are doing a mock drill. Yes. So no need to attend this meeting. You can come tomorrow. Tomorrow is the main thing where you actually will be given the questions.
It's not necessary, but if you want to sit and learn, that's entirely up to you.
Yeah. Right now we are doing the what are we doing? I forgot the name.
Vision Cipher.
Yeah. Vision Cipher. Yeah. Before that, what are we doing? I think this thing hangs too much.
So I'll just fold this code so you cannot see anything else, right? Is my screen visible? And more importantly, is the intended section visible?
Yes. Good.
Yes. So I'll tell you what happens. Okay, Ashik. Keep your mic on and keep giving me feedback that you understand.
Yes.
Okay. So what we are doing is, you understand the idea of a Caesar cipher.
Yeah, we shift every character of our given text by some certain amount of words and then continue the process for all the texts.
Exactly. Yeah, Srijita.
What are explaining the cryptanalysis? Are you explaining that?
Yes, I'm explaining.
The big
No. Cryptanalysis. Cryptanalysis substitution.
Oh, okay. We're just explaining how to get the maximum. Yeah, okay.
Yeah. So, did you have a specific question, Srijita? Or
no. Actually, I was coding and I'm just not being able to concentrate here, and then it's getting here and there. So yeah, that's.
You can mute me. Not a problem.
Yeah.
Not on Zoom. You can mute your, Zoom from your computer.
Yeah, I understood that.
So, getting back to this, since we know what a Caesar cipher is and how it works, we know that Caesar cipher is a kind of a substitution cipher, right? Whatever key I choose, we call it key, but what we mean is the number of letters that we are going to jump forward. to replace each and every letter, right? So I just generated a key, right? I generated a dictionary called the encryption key, right? And this dictionary is nothing but this, where the key value is, let us say, A, right? And F is the value that it is supposed to be replaced by. Just hold on.
Because we have passed 5.
Yeah, just give me a minute. Yeah, so A and the value that it should be replaced by F. Similarly, B, the value it should be replaced by G. The key of this cipher is given as 5 in my case.
Yes.
On the left side, if you see, there is the keygen. I fed the value 5. I could feed the value anything. I could feed the value 25. Right? Even then it would work. If the value is 25, then A would be represented by Z. B would be represented by A. Now, this is important to understand how this keygen is working. If I say 25, 25 means if I take 25 steps after A, I'll land up on Z. If I take 25 steps after B, I'll roll over Z and I'll again come to A.
Yes.
Right? So first we generate the key. This is not the exercise that would be performed by the problem giver, right? I'm just deliberately doing all this so I can analyze how my decryption or substitution is working.
We are setting the stage of encryption first, and then we are, on that grounds, we are trying to decrypt it.
Exactly. So this is my letter distribution of the original text. So we already made this function known as the letter distribution. If you have followed up to now.
Just
yeah.
Hey guys, I'm back.
Yeah, now you can continue.
So what was the thing was, okay, I'll go from the top for Mehul as well. I created an encryption key. Encryption key is nothing but a dictionary of the key values and the values that the key should be replaced by in the process of encryption. I kept the key in my case to be, let us say 5, right? I kept the key to be 5 in my case. Yeah.
Hello?
Yeah.
Yeah, just asking, this is the encryption key that you're using instead of that +1 or +2, anything that you're not fixing it.
I am still using that very thing only. I just made it into a function.
You're just using a key instead of fixing 1 + I + something, right?
I plus something itself is known as the key.
Yeah, I'm just saying that instead of writing I +1, you are just writing is as key and then defining it later, right?
Yeah. So I tell my function named keygen. So this is the function that I created. Very small function. This is nothing but a dictionary comprehension. I'll go through the dictionary comprehension after I've explained the entire algorithm if you do not understand it.
Yeah.
So I just created a dictionary comprehension where I just simply gave it the parameter I plus key. Now, whatever the key the user inputs, the key generator will make a dictionary according to that. If the key is 0, then A stands for A, B stands for B, and so on. If the key is 1, then A stands for B stands for A, and then C stands for B, and so on. So I generate a key. I declare the original text, and the original text is nothing but text strip of the text file, that is Sherlock in our case, right? So we all remember the format of the original text. It's all lowercase alphabets with no spaces and no special characters. We also created a function named as letter distribution.
Yes.
To find out the occurrences of all letters, count of occurrences. So I printed this, and this is the letter distribution in the original text. So we can see A occurred 19,696 times, and so on. And now there is a substitution encrypt. Right. So we all remember that we created a substitution encrypt function, which was doing what? Encrypting the original text using the
substitution method.
Using the substitution method and utilizing the key that was given by the user as a dictionary.
Yeah.
Now, what is this key? The key that we generated using keygen.
Yeah.
With a key of 5. Now, what we do is, after I have generated this encrypted text, I again perform letter distribution check on it. Right? So, this is the letter distribution of encrypted text that I get. Is this much clear? I took the original text. I found out its letter frequencies, the distribution of frequencies of occurrences of letter. I encrypted the text and repeated the exercise. So now I have both the distributions of the encrypted as well as the decrypted data, the original data and the encrypted data. Now we come to this function named cryptanalyze substitution, which is our main motive to understand. So the idea here is, statistically in English language, given that I have a fair sample of text, E is the letter that occurs maximum number of times. So is it fair to say that if in the encrypted text, I find out the letter which is occurring the maximum number of times, there is a very good chance, statistically, it has the highest probability of representing E?
Yes.
Understood?
Yeah.
Anyone who's not following? Okay. So statistically, the letter in the encrypted text having the highest frequency of occurrence has the best chance of being representing the letter E. Now, I'm assuming that I'm given a fair sample of text, and I'm using this statistical fact to my benefit. What I do is, let us go to this function. What I do is, I check which of the letters is in the encrypted text is actually being repeated the most number of times. And I assume that this letter is E. This letter has to be E. Now what I do is, this small task. We all know ASCII lowercase is the string of all small case, lowercase letters, alphabets. So what I do is, I find out the max letter in the encrypted text, whichever has the maximum number of occurrence, highest frequency of occurrence. I subtract its index. From it, I subtract the index of the letter E. This is the part that you need to understand. This is the actual main task being performed here. If you understood the statistics, that is very easy to program. Now, this is how you convert that statistics into key. Anyone who's not following?
So, sir, here our index of E is 5 only, right?
But the index of E is 5.
Sorry, it's 4 actually, because our indexing starts from 0.
Yeah, our indexing. Okay. So I'll clarify this part also. Let us look at it here. E has the highest frequency, that is 30051 in our text, original text. In the new text, the encrypted text, the maximum frequency is for J. Got the point?
Yes, yes.
So the maximum frequency is for J. So
Because
J has to
right? Yes.
J has to necessarily now be representing E. Right? So what I do is, I take the index of J in ASCII lowercase. What would be the index of J? Assume it starts from 1. Assume it starts from 1. What would be the index?
10.
10, exactly. What would be the index of E?
5.
What do you get after you subtract it?
5.
What was our key?
5.
Got it?
Yeah.
And regardless of the indexing, regardless of where the indexing starts from. Since we are taking the absolute difference between two indices, we'll always get that key.
Yes.
Okay. So there's no point of being confused whether it starts from 0 or the index of E is 4 or is it 5 or is it 6. It may be anything. As long as those are consecutive indices, this difference will always be the same.
Yeah.
That is the idea of Caesar cipher. So when we know this, when we have figured this out, the entire question is over. We just assign encryption key. I just name it a fancy word, encryption key, and I find out the difference and I assign it to it and I return the encryption key, which gives me the answer.
It gives us the key file. Yeah.
Right. Now, anyone who did not understand the logic?
I also want to add one thing.
Yeah,
in this cryptanalysis function, we have to return a dictionary, a predicted dictionary.
What does it say? Predict the key dictionary.
No. Like I have rechecked it again. You might have overwrote it. So it's written predict the D, only D. That's mean the dictionary. So we need to map the elements like we need to map. It's easy though. It's easy.
See, using what I've done is I have found out the actual number, which was
Yeah,
the key, but I have not
it's easy after
generated the
that.
dictionary. I have not generated the dictionary, right? So I'll simply call that same function that I created and I'll feed it the
correct
encryption key, right? And then what I'll do is
return that and store it in a variable and print that.
Right. So if I now execute this algorithm again, sorry, ignore that. This is the calculated substitution key. And you can, for word to word, match this calculated substitution key.
We actually got the inverse.
Original encryption key of the data. No, we did not get the inverse. We got the exact thing.
But we should get the inverse, right? I guess.
Why should we get the inverse?
Like
we should get the.
We should get F mapped to A, not A mapped to F.
No. Ishan, this is the key, or like what you can see on your screen right now. This is the key for encryption data. Hardik used that key to encrypt this data, and he got that key the same thing as the output for his code.
Okay.
So that
I understood the function, what it's doing and what not. I'm telling you, like for the encryption, we output the dictionary like A is mapped to J. And for this function, we should tell that J is mapped to A. No.
Actually, that's where I think you misunderstood it. And it also takes, some kind of a commonsensical approach to it. If I tell you, if I hand over a letter to you that is kind of encrypted, right? That is encrypted using this substitution cipher, and key is 5. If I tell you that you should decrypt this and you should tell me what the key is, if you tell me that F stands, that the value of F is A, yeah, then if I use your key to decrypt the message, then I'll get the wrong message.
Yeah.
So we have to output the key, which if used for decrypting the message, gives us the original text.
Got it.
And that remains the same. That is the same key as encryption.
Got it.
Anyone else? Okay, now let's do one thing.
Can I explain the last part once? But you said just before this.
Which part? Can you tell me the line number?
Actually, I got disconnected. I don't know what you were saying before this. Can I just explain it just once in one sentence?
Where did you lose me?
They started saying something about the encryption key and then I lost you.
Okay. So the encryption key is just a fancy name. All right. I just give it a fancy name. It is supposed to hold the key which was used for encrypting the data. Right. So our task is we are given the encrypted data. we have to find out what key was used to encrypt the data. Right? We do not have to decrypt the data, but we have to find the key that was used for encryption. So what I do is I follow the letter that has the maximum frequency in the encrypted data.
Yeah.
And statistically, I know that this should represent E. Got it?
Yeah, got that before.
Right. So what I do is, since ASCII lowercase is just a string of all lowercase alphabets, I subtract the index of the letter occurring most frequently in the encrypted data and the letter E in the ASCII lowercase string. So yeah, sir said that you do not need to worry about a particular way to code something. Try out your own method if you find someone else's code confusing. And if you find, if you find my code cryptic, then you can also try out your way to write the same thing. Like I'm trying to explain decryption and I'm encrypting my code in complexity. So that is not what I intend. But if you feel that this code is something that is not easy on your mind, you can try out your own way. Right? So if you are not clear on the logic, then you can tell me. But if you are clear on the logic, then you can either understand my code or write it yourself. Sujita?
I got it. We're supposed to find the maximum occurring letter and then relate it to E. That's the thing, right?
Yeah. So, and the last thing that I said about encryption key was, I simply, as Ishan actually pointed out to me, that we are supposed to predict the key dictionary, not the key. Right. So my code was actually predicting what the key is for the encryption, but I was not actually generating the key dictionary. So what I did was I just simply created a function named keygen, which is supposed to generate that dictionary. I'll show you what that function does. And I fed the key to it, and then it spat out the dictionary as a result. Is it clear?
Yep.
Okay. So now
and also, if anybody don't have any doubts, like if you have, asked it, and I think we should move forward. We have been stuck here for a while now.
Yeah, exactly. But if someone is still there who has not understood this,
yeah, just tell us. We will help you out.
Just tell us. We'll help you out. Okay, for people who are stuck, who are lagging behind in writing the functions, but who have understood the logic correctly, I'll do one thing. I'll just copy this entire code and I'll share it as a notepad file for
instead reference. Of there's a website called Pastewin. You can copy it over there and create a custom link. So share that link and we'll all access the document.
Okay,
I think you complete everything and then share it. Like I think some people are trying on their own or something.
Okay, not a problem, because then they would try to reference the things.
Yeah, because otherwise, like you give the code and like it's difficult to get through it without understanding what we were doing first.
Sure. So you can try out your own methods. Meanwhile, we can try and write the next function.
Actually, I have written the next few functions. So if you want, I can start. Actually, I have written the next few functions.
Sure,
next
you go
two
ahead.
functions actually.
I'll stop sharing and then you can start writing those.
Okay.
Start sharing your solution.
So should I code along or are you just gonna read it, all of you?
I was in the process of writing this function myself, so I'll complete it first and then I'll look at it.
Okay. So all of you can try and then we can discuss. Yeah, to.
Can actually someone once explain what you have to do in like encrypt one?
Which question are you talking about?
The encrypt beginner whatever that is encrypt.
Okay, so basically we have the password, we are given the password and we have been given this string. Okay, so suppose I have this example here. This is the string, the novel that we were given. Okay, these are the first few letters of that. And the password here is Daisy. Okay, so now suppose the first letter here is C. Now count से मेरा मतलब है कि index of C in alpha is 2. Okay, and index of D in alpha is 3. So this will become 2 plus 3 plus 1. That element in alpha जिसका index is 2 plus 3 plus 1 वो हमें यहाँ पे मिलेगा. Did you get it?
So the plus one because of the zero indexing.
Yeah.
Okay. So I take the original element, original character, take its index, take the passwords first, whatever character it's mapped to, its index, and then add them, and add one to that. That would be my new index for that word. Correct. Sorry.
Yeah.
Okay.
Okay, so sir has a few words to share. He'll be coming in the session for a few minutes. Does anyone know where is the joining link for this? For this Zoom meeting?
Yeah, you can go to the participants and go to invite, and there would be a copy invitation or copy invite link below it at the bottom.
Okay, right. Is Mehul still here? अच्छा मुझे सर पकड़ के बैठा था, मुझे लगा क्या हो गया. मेहुल हो रहा है?
नहीं एक्चुअली.
कहाँ हेल्प चाहिए बता.
I mean, अरे I'm just getting this पूरा fumbled and I'm going blank. I'm not able to think ahead.
No problem. Just slow down. Not a problem, man.
Yeah, I took most of the breaks here. I had taken 4 breaks till now. Still cannot get back on track.
No, not a problem. Like it takes time to get used to do it all in one sitting. Even I cannot do it in one sitting. I need to take breaks as well.
But it seems like you guys are managing pretty well. I'm getting very complex.
No.
No. Look. Mehul, look.
It's just a zone.
Yeah, like Mehul, you don't get frustrated because you can't do it. That's the main problem that happens. It happened to me a lot as well, and it still happens to me. But firstly, break your code down into pieces.
Scroll up, please.
Check your code part by part. If this works, then fix it. Then okay, I don't have to go back here. This works. I know that this works. And then go to the next part. Check and then comment and break it down into pieces. That helps a lot. Trust me, I've been there. I know how it feels. Like you can't get it and then you get frustrated and then you're like, I can't even understand simple logic. I've been there, trust me. Like just try to break it down into pieces. Try to first clear your mind. Try to look at the question in a new way and try to break your code down into pieces if you're trying to debug it. Helps a lot.
Okay.
Try going logic by logic, line by line, instead of putting up the whole logic together.
Exactly.
Just think what I have done till now and what my next step should be instead of what my final step should be.
Yeah, go line by line. Exactly. Go next step. Exactly. Look at your next step. What do you want to do next rather than what is the whole final result?
One second. Anushka? Yeah, so you seem to have written a very wonderful line. Alpha.index password x modulo n. Can you please explain this?
मुझे थोड़ा याद करना पड़ेगा, एक सेकंड.
I also had the same doubt.
You should start commenting your code.
I can help you out.
Yeah.
See, n is the length of the password. So हमें चाहिए कि suppose यहाँ पे जो word है ये daisy है, तो हमें ये चाहिए कि जो first यहाँ पे letter है वो d से increment हो और फिर जो sixth letter है वो भी d से increment हो, इसलिए modulo आया. तो यहाँ पे अगर x 6 होगा और n 5 है तो 6 mod n करके वो 1 आ जाएगा.
Okay.
तो वापस d पर आ जाएगा.
So you are changing all the elements representing one key and then all the elements representing the other key and then all the elements representing the other key. That's what you're doing, right? मतलब अगर मेरा password is ABC, then you are changing all the elements जिनको पहले मुझे 1 से increment करना है. Then you are changing all the elements जिनको 2 से करना है.
नहीं. मैं सिर्फ पूरा जो string है उसमें एक बार वो कर रही हूँ, एक iteration में ही हो रहा है. जो string का first element है वो increment होगा, फिर second वाला होगा, फिर third वाला होगा, क्योंकि ये line एक बार में सब कुछ कर रही है.
it can be more understandable if you write your name, like if you write your full name in one string and put up a short password below your name. So you will get it more clearly. No, I wasn't meant to write here. It would be good if you write it on the register, like if you don't understand the code.
Oh, okay. You can do that. That can test proficiency should be good. Did you get it?
I did understand it, but I'm trying to figure out the syntax of this line.
Am I audible, guys?
Yes, sir.
Hello.
Yes, sir.
Okay, awesome.
Yes, yes,
So firstly, it's going very well so far. Okay, the upside of it. But a small thing that you people, as I see, are worrying is you're unable to complete. You're probably 60%, 70% through, and it may be difficult for people to complete tonight. If you think so, I just came to give you a pep talk that you needn't worry, because you have come to a very good stage. This much alone is enough. If you can get someone up to this level and let them go there saying that, finish it. And you guys also sit and code individually. That should be more than enough. That should be a super success. Okay. So know that you guys have come to a very good stage. And beyond this, you need not break your head. But if you want to go ahead, finish it, please finish it. No issues. But feel confident is all why I stopped by to tell you people. Anything in particular you wanted to ask?
Yeah, sir. About the cryptanalysis question.
Okay.
Yeah, in that, what we are doing is we had two methods. One, either use the previous dictionary that we created on the top, and that gave us that E was the most frequent letter. Then it gave us that L was the most frequent, whatever. Sorry, T was the most frequent. After that, it gave us that order, and we could find the ratios from that. And once we had that Hasbro ratios, we could do the same thing with the encrypted data and compare them, and then figure out what letters are what. That was one method. Or the other method was that we have we take the encrypted data and we find the most frequent letter, and that letter must be E. We find the difference between E and that letter, and that's my key. And that's how we solve it. So
no, it's just this. You figure out the ranking of the letters according to Sherlock. See, it may slightly vary from the actual frequency ranking given on Wikipedia. Slight variation. That's because this document is not enough. You need a very big document, but still, this document is fairly enough for you to do some engineering after you figure out the frequency ranking. But then let's not do that engineering. Let's make the hackathon even simpler by declaring a ranking of the frequently occurring letter somewhere in a function. Call it the truth values or something like that. Okay. The most frequently occurring letter should be the first letter in the list there. Second most frequently occurring letter should be the second element in the list there. You can also use a dictionary, but list is sort of easy on your minds here in this case at least. So what you do is, in your actual, when you want to cryptanalyze, when you look at the 1k plus 1, 2k plus 1 elements, there you run this kind of a frequency attack. But sometimes you may not get a match. Okay, for that, what you should do, should take everything, 1k plus 1, 2k plus 1, 3k plus 1, and so on. Also 2k plus 2, 2k plus 2, and so on. That's all is the primary idea. You get this right, Atharva?
Yeah, so what you're saying is that in the input, instead of just giving a input to be a single text, we should also give an input as a dictionary or a list.
Correct. Goes without saying, the true values you should give.
Yeah, not
whatever
true
you
value.
call
Yeah, yeah, the true values of the original text, the ratios of the original text, or
the
yeah, true values.
distribution
Yeah,
of
distribution
letters of the
letters.
original text.
Okay.
Yeah, and it is assumed that this was not you didn't know the plain text, but you just figured this out. You have engineered this.
Okay,
the true value given to everyone. Okay.
Right. So we have the dictionary and we have the encrypted text, and we're putting that into the function.
Correct.
Okay.
Is everyone on the same page here? Is it clear?
So we could also use directly the dictionary which we obtained in one of our functions, and then take the values of each element and make
that's what
it
you
a
should do.
list.
As create a temporary function with the actual values there, and distribute this dictionary to everyone. Explain what this dictionary is and distribute that to everyone. That's all.
So maybe we just need to make one small change in the original Python document, that instead of just giving an input s comma d.
Yeah, no problem. Correct. You can change that. That's right. Okay. Or d can be kept global.
Yeah, but in the function we need to give an input d, right?
No. If it's kept global, you need not give that as function. I mean,
in that. Okay.
Keep that global. Also, this is not a good idea to keep anything global, but in this case, it is easy for people who are starting off. It will be slightly a little too much for them otherwise. Keep this as a global truth. I mean, universal truth that can be invoked by anyone. Make it appear like that. Okay. Awesome. So anything else, guys? You guys should not feel low right now. This is a time for you to. I've been observing here and there. You guys are doing very well. This should be more than enough. Okay. Yeah, Parth, quickly. Yeah.
Sir, when we explain the ideas behind Vinzera Cipher tomorrow, so how do we illustrate it? Like you were able to illustrate us on your iPad.
Okay. I'll tell you exactly how to go about. Yeah. I'll tell you exactly how to go about. Before which I should tell you people that Hardik, you have done an amazing job. I cannot imagine the team without you. Okay, you have been the driving force there. So people, what you all should note here is, as I was mentioning there, Hardik is trying his level best to write the code and explain that to you. Okay. It is very difficult for any X to explain it to Y, although Hardik is giving his level best. But then there is another problem that Y may not be able to see it the way X sees it. Okay. In case that happens, what you should do is get as much as possible the pseudocode version of it, and then you try coding it, or be confident that given enough time you can code it. Okay. Tomorrow, what you do is you should not be telling anyone how to code individual functions. You should just be giving them logic and encourage them to code. Someone in the team will figure it out, and others will horizontally copy it. That's okay. You need not know how to do it there itself. Don't try debugging. Ask them to use a debugger, because that was a prerequisite for this session. Right? They are not supposed to come without knowing debugger. Right? Or let them learn there itself. Big deal. Okay. You will just be there as a motivational mentor. Okay. Any algorithm that I teach, let me just quote you just to fill in confidence in you people. Okay. So the dating problem, if you remember that we spoke. Okay. Basically, if you ask me to write a code for it, I'm not prepared. I may take some time, but that doesn't stop me from being a mentor for all you people. I know the crux. I know the idea. Okay. I'll just go ahead and then tell you people and ask you to code. Tomorrow, you all will be replicates of the professor. Okay. Professor doesn't code, not expect in no other course professors code. Okay. Only in some of our courses we end up coding, but it's not required actually. You just give the pseudo code. The rest is sort of clerical. If you see syntax अब नहीं आया तो एक दो घंटे के बाद आएगा. कोई बात नहीं, इसलिए हैकाथन बोलते हैं ताकि सुबह से शुरू करके आप लोग रात तक you can figure out. But I one dare for all of you. This entire thing can be completed in less than an hour if you're experienced. If you want, we can do that exercise sometime. All of us will sit and boom, 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 share the screen, and all of us should finish it in 1 hour. Maybe is far-fetched for some of you, if not all.
Maybe two.
So we'll give it 2 hours, maybe maximum of 2 hours. And I can tell you within 1 hour, you can finish everything. You just need confidence. That's all. Some syntax level things which you need not look up. Once done, second time you will not look it up. But you should not memorize anything. Okay. Now, anyway, I am confident each one of you. Let me name all of you. Hardik, Ashik, Atharva, Mehul, Harshit, Srijita, Anushka, Ishant, Parth. I'm not so sure. I didn't see you much around, but even by the look of it, I feel even you belong to the league. All of you can code really well, and tomorrow you can be great mentors. Okay, please don't lose hope. Whatever you understood, whatever I did with my iPad, see, I inspired you people to write the code, right? Yes or no? I inspired, and you people are writing code right now, correct? Similarly, you people, one second, unless I switch on the video, I don't feel confident being a good mentor. I'm sorry, I switched off the lights. If I switch on the flashlights, it'll it's a little dark around here. It helps me sleep, otherwise I cannot sleep. Okay, so it might help for you to observe that what I did with you people is I just motivated you, and you guys call it up, and then you're able to code. That's all you're expected to do tomorrow. That's it. Whatever I did with my iPad, do it personally over a chat, or use a mic and video, and then go ahead and then do. That's it. As simple as that. Don't break your head much. You're already through. Okay. So my suggestion would be, few of you stay back and then finish the code. Majority of you can even consider going to bed right now, so that you can wake up early and then start off afresh. Quickly to summarize. Yeah, Hardik, you want to say something? I'll just come in just a minute. Okay. Quickly to summarize, there's a plain text. Okay. You do the substitution idea, pretty straightforward. You don't know how to code, they will code. One of them will do it. Others can copy it. The idea is more important there. Okay. Once that is done, you ask them, can you guess? Obviously, you can't guess. Then you reveal this frequency attack like idea. That's the aha moment. You should ensure that you give that aha moment. It's okay if people are not coding, but the wisdom that this frequency, the coughing will, English is trying to behave like Sanskrit, but it coughs like English. Then you can catch English and say, this is not Sanskrit, this is English. That's all we are doing in frequency attack. That's the aha moment. Don't miss that. Rest, don't break your head at all. Okay. And you move ahead, and slowly you give another aha moment, that the very idea of Vigenère cipher. The aha moment there, just the idea how to encrypt is an aha moment, because it is deep. It appears like it can never be broken. Just like the substitution cipher, that's called substitution cipher. You put some letter for some letter, right? Unlike substitution cipher, this is a very deep idea. Okay, got it? That's an aha moment. Don't miss second aha moment. The very definition of Vigenère cipher, and convince them that, look, dude, you will not be able to break this. But I'll prove you wrong. Okay, go ahead and quickly declare the Amavasya idea. One, Amavasya comes in cycles. There is a K there, that is a cycle. And in between this, there's an aha moment, which is, in case you get to know K, you can decode. Do you realize it is same as the substitution cipher? The third aha moment, don't miss this. Fourth aha moment is the new Monday. Okay, in cycles, this happens. There's a problem. This is, you take it from me, I'm an expert. This works. Don't tell them how this works. Of course, you guys also don't know. Okay, you stop there. I will come and continue maybe. Or leave it for them to figure out. Movie mein sab kuch nahi dikhana hai. At the end, you should leave it for the people to figure out what is the ideal ending according to them. Right? That makes it even more interesting. Correct? Okay. So feel confident. You guys have done a great job. I have a compliment in store to Guru Raj. Guru Raj wasn't a volunteer, but I see him throughout the session. Very impressed, Guru Raj. Please let us know in case you have understood everything. You can come in as a volunteer tomorrow. Okay.
Actually, I am a volunteer.
You're already a volunteer. Wonderful, wonderful, wonderful. Very nice, very nice. So Mehul, we will consider everyone who has been there until this point as volunteers. Okay. I also see Yash Chowdhury, Punya Prakash, Ayush Raj, Ishant, of course, is there. Someone called HJ. That's why I say, please put your names so that I can remember it. The point is, I am familiar with it. Okay. So all the best. Good luck. You have done an amazing job. This much is enough to make you will see tomorrow's hackathon will be a super duper success. I have conducted this hackathon without volunteers. Just send this document and let people work in teams. They do a wonderful job. On top of this, we have volunteers who have done half of it. Imagine how successful the event will be. All right, don't worry, come until that point and tell them, dude, I have done only this much coding. Come, let's do it together. That way you will be feeling confidence in them that, oh, this dude also knows only this much. Now let me try to beat him. It's okay. I mean, so they keep saying, no, the story of Mahabharata, that the best moment for Dronacharya was when he was defeated by Arjuna. So please feel free to be defeated. As teachers, you must accept defeat. Let them defeat you. Preferably don't code at all. Make them code. That's all. Okay. Word of warning. Don't try to debug. Second word of warning. Don't try to look at their code. Frequently occurring problems. If they're experts better than you, you look at their code. Otherwise, if they say, look at the code and help me, say no. Code should not be seen. This is the first law of Sudarshan Iyengar. He has told us and we are going to follow it diligently. No seeing each other's code. Write your pseudo code, I will see it, but not your Python code. Okay. Python code is like very good food. You eat and you vomit. That is Python code. It's very difficult to see that. It stinks. So you look at the fresh food, that is pseudo code. That is enough. Okay. Got it? Otherwise, you'll be stressed and you'll not wake up for the next 1 week if you keep seeing the codes of different people. Okay. Teach them debugging here and there if you want. Some PDB. Okay. Again, you may not remember, but you will do well there. Just do NLL, N colon colon L, semicolon semicolon L, and then print some variables. That's all. Keep going. Okay. Done? Are you all good to go? Now go ahead, stay as much as possible and call it quits at some time. This stage is more than enough. Yeah, on to Hardik and others can also ask questions. Anushka, I'm coming. Yeah, Hardik.
So I was just trying to say that someone pointed out how are we supposed to explain what you explained as using an iPad. So I actually happen to have a pen tablet. So would it be helpful that we take in the entire session? I explain it using the pen tablet and then we go into the breakout sessions, or you come in and you explain it and then we go into the breakout
sessions. That can also be done. But let me just give another quick pep talk in telling you that, do you people like movies or do you people like books?
So personally books.
See, some people say books. Real intellectuals prefer books because books gives you the dimension of imagination is kept open there. You don't lock it with the movies. You say, I first read Harry Potter. I had no clue how he looked like. I mean, that he looked like the way he looks in the movie. When I read the story, he was way better in my imagination. The moment I saw the movie, it spoiled it. Okay, in fact, all the characters, the Professor Dumbledore looked like whatever, I mean, Vishwamitra for me. Right? But then when I saw him in the movie, it was such a disappointment. Right? Where am I getting at? You actually don't need an iPad if you can talk and convince them well. Okay. Talking and convincing is not an art. It's just an offshoot of how much you love the topic, how much you want to see the aha moment in the eyes of the people. Okay. With that kind of whatever madness, sort of craziness, you should go and in a positive way, try to infect the idea in people. It should be like a piece of gossip you want to say to your friend about another friend. Right? We keep waiting for that moment, you see. So make this as a piece of scientific gossip. You actually don't need to worry much. As Hardik rightly put, he has an iPad, he has a touch screen, I mean, whatever, tablet. I have one. Some of you might have access to it, or you can do a jugaad. Place your camera on top of 2 books and then write below. I mean, that's the easiest way. And it's much better than any of my iPad or anything else. You could also do that. Or keep it very simple. Inspire them to code. You don't have to explain anything. Tell them this is the idea. That's all. This is the algorithm. Better even, ask them to read up the book. In one part of the book, beautifully illustrates this rotation idea. And Simon Singh is a wonderful writer. You read his explanation. My explanation is nothing in front of what he has written. Right? So you could also resort to that. There are so many ways, but keep your mind open. One very dangerous thing is you not feeling motivated or confident about what is what. You all are confident. I was watching our own YouTube video. You all sort of carried a confident smile on your face when I explained the KK plus one thing. I realized all of you are now initiated. That is enough. Okay. 2 things are required for a good teacher. With this I end. Okay. One thing is, both are required. If you have only one, you will not be able to do well. One is you should love the topic. Second thing is you should love the students. Okay. If you love only one thing and not the other, it will be a mishap. So ensure that you love both. Go ahead tomorrow. As they say, the goddess of knowledge is with people who want to give, who love these two parameters. So your goddess of knowledge will be with you. All right. So take care. If you have any more questions, I'll address. Otherwise, we are done. Anushka, please go ahead. You raised your hand, right? No?
No, sir.
Okay. Okay. Atharva. Unmute Atharva.
Yeah. 3 questions, sir. One, when will the hackathon be starting? Tomorrow morning? And when will it end?
Okay. So tomorrow, very informally, we start at 10:45. Okay. I'll come somewhere in between and give a small pep talk and then go away. That's it. Okay. Otherwise, I'll be going on in circles. I mean, circularly, I'll be visiting a BB1, BB2, BB3, BB4, and then random rand int 1, K CC. Okay, I will come there and then see and then go back.
Random dot choice group number CC.
Yeah. Random dot choice group number, exactly. And then go there and ask a few questions, see who is managing stuff there, and try to be there if they're unable to manage. Shout out for help at any time. If you want any help, quickly see, volunteers group is open for all of you. So I'm just let's say, for instance, Hardik immediately requires some help from Ashik. Okay. So Hardik may not be from Ashik. He says, I am stuck here in this room. Can one of you please come and help me out? Boom, fly there and then do it. Okay. Preferably this flying squad should be your Hardik. Okay. In case you want any help, please put him. Hardik, just go there like chief minister cutting the ribbon. Quickly go there, fix it, and then come back. If you don't know, motivate them and then come back. That's all. If you think you cannot spend so much time in finishing the code. Okay.
Or if I myself get cut, just motivate them and come back.
No, as teachers, we can convince them or confuse them. That's a popular quote for a successful teacher. I didn't mean you should do it. I just said that don't try the coding part. Just give them these 4 aha moments, and leave it to them. Let them code. They will be able to code. I want them to know where they stand tomorrow in coding. That's all. Given 12 hours, you all will code this. I'm very confident. Without seeing the code, you all can easily code it in given 12 hours tomorrow. Okay. They can also do it. You just be mentors in the background. Okay.
So just one small question. Are we supposed to tell them that they can look up some sort of modular functions or something on Google, or do we tell them not to look at
Google is perfectly fine. The code that you people have written, don't give them. It
No,
becomes very
we
easy.
won't give them.
No, don't give them, as in tease them enough and then give them, is what I meant. Okay. Push
For
them to
example,
the
if
limits. Push
for
them to the
example,
limits. You see, half the marathon time is over. Let's say 11 o'clock plus 6 hours is over. I'm planning 11 to 11. You see that up to what is 11 plus 6, 5 o'clock. They have not even finished the first 2 functions. Then you go and tell them, look, these are the 2 functions. Now you go ahead. Okay, let them play around and then do it. Ask them not to give it to anyone. Okay? So this should be a good idea. They can Google, they can copy. This hackathon session is very open. Some of them needn't even be serious. Like how Atharva was trying to solve the math part of it. Right, Atharva, you were tempted to do the, why is this shifting happening? 3.8 to 4 point something is happening. Right, you were saying during dinner time, we will discuss that. Like that, if someone wants to simply sit with a pen and paper and then discuss that, encourage them. Okay, or they don't want to do anything, just want to be around, stick around, chew gum, and then listen to what you're saying. That's also perfectly fine. Okay, it's tough to do when 9 people are coding. One person being an outlier there, he will not feel good. Either he'll leave or he'll start coding. That's psychology, right? So I don't think you guys need to worry about anything. Just keep it very, very free. Extremely free. Let them do whatever they want, but they should not disturb you. Very clear. If they ask a question, ask someone to answer it, just the way I did with volunteers early today. Okay, ask someone to answer it, or say, think I will not be able to give any further hints, and go silent. Okay, you can always say this is out of the scope also, in case it's out of the scope. All right, confident all of you? Mehul, confident?
Sir,
I came mainly because of Mehul, because I'm sure you are strained and stressed given so many things you are handling as a primary volunteer and also sitting and coding. Don't worry, things will go very well. You want to say something, Mehul?
No, sir.
Sir, I want to say something.
I hope you don't have a headache because of which you have a headband, no?
No, sir. I just tired whenever I think I'm losing it.
Oh, no. You guys are not losing it. This is more than enough. You know the 4 aha moments. That's a prerequisite for you to go live tomorrow. If you know it, then forget about the code. Okay, they will code. You sit with them and then make them code. Sit together and do some pair programming. Yeah, Hardik, you're saying something? Unmute. I think we both are clicking the same. Okay, tell me.
Hardik. I didn't have anything to say. I was doing nothing.
Acha. Anything else, Harshit, Anushka?
Sir, one more. When will our next lecture session be after this?
All that we have discussed. See, I'll tell you primarily the reason why I wanted to have this session is to get to know you people. Okay. I somehow believe, and it has also been the case with many people, many students, many teachers, that once you get to know each other, learning becomes easy. Sometimes because you know each other, you tend to learn better from the person, right? Than me being just in front of a DSLR camera and give you lecture videos that are, a YouTube playlist. I thought, let us connect with each other. And once connected, we can always set a random call like this and sit and discuss all that I have posed so far. Like the closest pair problem. That's a very deep question. Closest pair problem, order n time, is a very deep question. Very nice. More deeper than this entire hackathon event. Okay, maybe that's the next hackathon event. I don't know. By that I mean I will be sitting and then discussing the balls and bins, how it's log-n, okay, and the dating problem, and then hashing in general, n balls into n bins, right? The log-n thing, right? And various other things that I have discussed. Maybe finding a prime number, which is also very interesting and also very deep, right? So we will do a lot of it. Nothing to worry.
Sir, I had some, because there are a lot of ideas which are not usually taught to computer science students, but are taught to electronic students. But I think those ideas are necessary for both of them.
I was listening to you're from DU, and then Athara was going on and on asking you questions, and you said this is live and stuff like that. Okay, I was listening, and that is when it struck my mind that, by the way, where is Atharva? Boom. Atharva is here.
Sorry,
okay.
Lost my internet.
Oh, no problem. So many ideas in signals, okay, is essentially data sciences. Just that it is old wine in the new bottle. Data science is a new old. The old wine has been the least squares method originated in electrical only. Almost all ideas. That's why compartmentalism of subjects is bad. That is what is causing you problems. I give you this 0-1 problem, boy-girl problem. You're unable to answer because of the compartmentalism of subjects, according to me at least. Okay, I'm not an authority, but still my observation as a teacher says that these are all very cute ideas. It should be independently taught with prerequisites respected, of course. But then over compartmentalizing it, even the teacher who's teaching may not know this side and that side, and he will take a very the view of a shielded horse, as they say, right? So keep your mind open. Hardik will be very happy to do a session on signals, starting from what one means by the Maclaurin series, and then what is sine wave, and how every single wave is a combination of sine and cos wave. Absolutely amazing. Discrete cosine transform, on how you can make a image get shrunk onto the tip of a pin. Right, these are all very, very mystifying. You will not, I keep saying, no exaggeration, absolutely no. You will not have respect for magic shows after looking at these algorithms. Nothing can be better magic in nature than these beautiful algorithms. Okay, and the idea of SVD, singular value decomposition, right? That again is from signals only, right? I think that's what you are trying to say, right? Some aspects of electronics is indeed algorithms. We can take some problems from there.
Sometimes in signals, and sometimes there are certain hardware structures which are not taught which are taught to us in algorithmic way, and we are like thinking like this.
There's something called linear feedback shift registers, which you people
use. The Booth's algorithm for multiplication, the entire basis of multiplication in hardware.
Correct. No, there are many such methods. The Shor's algorithm and the Kasturba's algorithm. All these things are actually algorithms to multiply. Okay, and then what is that? Fast Fourier transform to multiply. Again, pure magic comes from signals only. Okay, now I was telling you something. What was that? I was referring to something important and I lost it.
Linear something.
Linear feedback shift registers. They're called the LFSRs. Again, electrical guy's favorite, electronic guy's favorite. That is how random numbers are generated. There's a polynomial there, hardcore algebra there, not the algebra that you study in high schools, the algebra that you study in higher mathematics. like Galois theory and all. There's a beautiful polynomial there on a hardware device which spits out random numbers, which is computer science, according to the stupid compartmentalism, right? But then all this put together is how do you generate random numbers nicely? Here is get whatever you want and get things done, right? Okay, so that should be enough. So you people go ahead and then sleep so that you come back with a bang tomorrow morning. What you need to look very fresh and not appear drowsy or demotivated. Feel free to stay back, discuss, but according to me, you're good to go tomorrow. Over and beyond that, it is your freedom. Do whatever you want. Okay?
Sir, I don't understand how this connected back to when our next lecture is. I lost my internet connection.
Next, you asked and you left. That's why I was wondering where is Atharva. I
asked and I lost my
Atharva is missing. Okay, so next lecture I was telling that we have posed a few questions. Answering those questions would require more than a couple of terms. So whenever you guys are free, whenever I am free, we'll sit for we should do it more like this Instagram live and Twitter live sessions that people do. You should popularize your BSc program using these kind of activities. We'll go live like this. Okay, and then try to see if we can solve some problems. I'll just switch on my camera and then code. That's all. Pose a problem, birthday paradox or dating problem. We'll just try coding together maybe, right? So the next session is when you all are ready, maybe immediate. Okay, but I think you need 2 days of rest. If not you, I need 2 days of rest.
Yeah, sure, sir. No, like when do you have time? Because we have the n square and peace problem, right?
Peace problem, yeah.
That's the next.
That's the next hackathon.
We have a
you
lot
guys
of
are
problems
see. That's where all these things help us identify who is who, what is what, right? That problem I'll do only with you guys, not with the entire class. Maybe it's easier that way. And then I'll set you people to go and set a thief to catch a thief in a positive sense. Train a volunteer and he will go train several more, and they will also become volunteers to teach others, right? So let's do something like that. Once you're ready, we will do that. That involves hashing. Closest pair problem involves the idea that I told you about balls and bins, the DTO, the secretary's dilemma, right? It involves that idea there, right? We'll see how that can be done. Okay. All of you, please cheer up. It has been strenuous, I understand, looking at the monitor and trying to decode the code and stuff like that. You'll do very well tomorrow, and let's meet tomorrow with all fresh energy. Okay.
Yeah.
Also, you look like you have another question. Yeah, I know. I could make out. Nice. Okay, go on.
Sir, I sent you the code. It seems to work for the fractal problem.
Oh, I see. Yeah. Wonderful. Okay, the fractal idea is very beautiful. I'll tell that and then end the discussion. Ensure that I don't go beyond a minute after Yash finishes his question. Yes.
Actually, I was trying to do that problem with the divide and conquer rule. Means I have studied that whole chapter of divide and conquer rule. Then I was trying it.
Hint: it's a 5-line recursion code. That's all. For n equals 4 case, n equals 3 case comes a few times. 4 times sir. Rather. N equals 3 is n equals 2 4 times. Very simple. Okay. You know what this question is? This is called. I'll not tell you the name of the. Idea. You will Google and there's code available. You will use it. At least I'll not leak the title. This, what it does when you're moving in 2 dimension.
Yes, sir.
Okay, you must ensure that the distance between I and j, any 2 points. Okay, distance formula says what is that square root of the sum of the squares, the differences, blah blah blah. There is some number that you get out of 2 points. Okay. In that matrix or coordinate, two-dimensional coordinate geometry, whatever, that and this should be correlate. Got the point?
Yes, sir.
When is your previous life and the current life a correlate? If happy moments there at every stage of your life, when you are 10-year-old, you got a Xbox in your previous life. In the current life, when you are 10-year-old, you should get a PlayStation. Okay. Or a very powerful gaming. Back then there was no Xbox, just as an example. Okay. So then it's these 2 lives are correlates. There are 2 lives of this coordinate geometry. One life is you move discretely like this using that whatever you did. whatever I showed.
Yeah.
The second life is actually simply the distance between 2 points in the continuous case using the typical Pythagoras theorem, which is distance formula.
Yes, sir.
Is there any distance formula? It's Pythagoras theorem, that's all.
Yes,
The
sir.
line there, how do you measure that? This square root of this, get that, simple. Okay, that and this, if points are away in that world, point should be away in this world of tracing. That's all. This is the best way.
Yes, sir.
And one mathematician proved it, that this is the best way to fill the space, respecting the distances. If you are this much away in this method, that correlates with the distance that you actually get in the distance formula.
Yes, sir. Okay. I would try it. Means, sir, I was reading the book Joy of X. So is it included in that also book?
What is included? This part, this is not included. That book has various other things. The book is, I mean, book
Yes,
one should read before dying. If one reads that, it means that they're eligible. Now it's okay. They say, no, I'm now settled. My kids are settled. Now it's okay if I go. Old people say that, right? So like there is a, once you read Joy of X, it's okay. There is nothing much to enjoy in life. Beautifully written book. Please read. And also I think we should have some 10 books and have a book reading club too, where we come and discuss perspectives. These days podcasts are very famous, right? Probably we should have a BSc podcast. Pod wahan pe ho gaya, ab cast karna hai bas. By pod I meant Python online, what is that? Programming online degree, right? That's what POD stands for, correct? Okay, so perfect. Let's call it a day. Otherwise, I'll be cracking more PJs because I'm feeling very sleepy. Take care, guys. Good night. Sweet dreams. And maybe continue with, face more errors, fix the code, finish all the function, and then sleep. Either ways, you will do very well tomorrow. Bye-bye.
Good night.
Bye,
Thank you
sir.
so much.
Good
sir.
night, sir. Thank you, sir.
Good night.
Good night. Good night. Sweet dreams.
So who all are staying?
I have one question because I lost my internet connection.
अरे नहीं वे एक क्वेश्चन ज्यादा इम्पोर्टेंट है सर होस्ट थे एंड इफ सर शट्स डाउन हिज कंप्यूटर ये मीटिंग बंद हो जाएगी
I don't. So we are the co-hosts.
Second host भी है ना?
Yeah,
We'll
we
start
have the
Google Meet.
co-host.
Google Meet.
Yeah, we'll
Yeah,
move to Google Meet
then
nevertheless.
we'll have to shut down this live session. That is
Oh
what I'm
no! Wait. I mean, I see. It's nice that this is going live. Somehow, it's sort of the emotional factor is that you people will like seeing this after 10 years down the line.
Yeah.
Yeah,
Right?
actually.
Tomorrow's event is not recorded, unfortunately. We cannot. In fact, today's session, probably it is all naive and not so interesting, but 10 years down the line, you will enjoy like anything. We humans will live for memories, right? So let it go on. Please finish it and then
maybe
live on.
maybe we can show this in a resume.
Yeah, and also show it. Proof, right? And show it to your kids
OG
also,
batch.
right? Kids or prospective partner and things like that. So let it go live. Take care, guys. Bye-bye. Bye-bye. I am leaving now. Bye-bye.
Good night, sir.
Bye,
Bye.
sir.
Good night, sir.
Okay, just a suggestion. We'll continue with the question which we were doing till now, and then we will start early morning if we want. But then continue now. It is very much difficult.
Yeah,
So we can do what we can do is like those who want to sleep can go back to bed. So those who want to stay will stay. We will fill you up tomorrow morning. How about this?
That's what I was saying.
Can you then share the file that we write along with the notes and everything?
Yeah, the
If we
file
have
will
some
be shared.
problem,
We will
Karthik is
share the
already
night
creating
before.
the file.
We will share the file before going to bed to the Telegram channel. You all guys can read it in the early morning, and those who didn't understand it will fill you up. Those who are staying.
Yeah, that's true for the ones who will go, but then you all will stay and you all will be also stressed up, no? So for that reason.
No, it's
Just one
It's like up to आदत सी हो गई है.
can I say something?
Yeah.
At least what we can do is discuss the list of the functions, even if we don't complete it.
Oh, that is better then. Yeah.
So there is also one suggestion which I like from the sir. Since we are all on Telegram group, if we get stuck somewhere, we'll put the chat on the Telegram group. Like I am in this room, and whosoever is free can join the Telegram group and solve the issue and come back to his room.
Dik sir must be there.
Like anyone who is free can do that. I guess.
First of all, I'm not a sir. Please stop calling me that. Refer me by name. Refer me by my first name. Not a problem.
And one more thing, कोड खत्म करके सोएंगे तो सुकून के नींद सो सकते हैं.
Yeah, actually I want to complete the code.
On the contrary, अगर कोड खत्म करके ज्यादा सुकून की नींद सोगे तो कल सुबह टाइम पे नहीं उठोगे.
हाँ,
तो एक कोड रहने देते हैं, एक कोड रहने देते हैं.
एक आध फंक्शन एंड में छोड़ के सोएंगे.
थोड़ा रिफ्रेशमेंट चाहिए. That is what I meant actually. इसके लिए सुबह जल्दी उठेंगे ना, so we have at least 3
For
hours.
example,
okay, hey,
like going for my, personally, I'm not an early riser. I cannot work if I rise early. I'll lose my shit and I'll not be able to do anything. But I can stay up late at night, finish my work, and then sleep until the afternoon the next day.
I can have a 3-hour sleep, but I would like to finish my work.
Yeah,
okay,
sure.
So, let's do one thing. Let's do like agar 11 functions hai na, let's do 10 of them and let's leave one so that at least we have something to do during the hackathon if we have free time on our hands.
Yeah, works.
Make sense?
No, I don't think we would have the time.
I'm thinking
during the hackathon, तुम ये मान के चलो during the hackathon, at least for the first 4-5 hours, you won't have the time because
how about we keep going instead of discussing, like we should continue.
We'll have to keep sorting out problems. The one thing that we could do is, let the hackathon be over tomorrow, and for those of us who are still left, we can sit together the next day and try doing it ourselves. Just we'll not look at the solutions. That's the best thing that we can do.
Perfect.
The last code.
However many functions do you want to leave out?
Sure,
as long as you're comfortable, right?
Sure,
and the other thing that I was going to say was, in the meantime, if someone gets the time, rather than attempting the code, or rather than putting all your energy in forming the code, we'll all go and try and read up the book that Sir today gave us, right? And we'll try to figure out how the Cipher is actually working, so we can better understand how to give, how to deliver those aha moments.
That book is itself like a pseudocode.
Yeah, exactly.
Like if you read it is.
I was going through the first chapter and I usually skip 4 lines and then skim through the entire book. Because I have this habit of reading, so I'm a fast reader. So I skip 3 or 4 lines and I still grasp the concept. But this book is so interesting, I do not even want to leave out a single word.
The way the author told the stories is quite interesting. How things are encrypting.
He's not leaving out history, whether relevant or irrelevant.
Yeah.
So I suggest that we should, like tomorrow, if we have any kind of a time in between the session, then we should focus
that makes a lot of sense. Makes a lot of sense. Okay,
so we have spent ample time on trying to code the Cipher. Now let's understand it.
So just one quick note to cryptanalysts, everyone is on the same page. If not, please tell us, we will help you. Like any kind of problem.
I think Sir was telling about a different approach.
Yeah, I want to talk
about
that.
About different. Yes, my approach is wrong.
Yeah, I guess Sir was telling that approach I discussed using the two values.
So I had used the same approach. I had created another dictionary which contains the probability of the initial text, of each letter of the initial text. Then what I'm doing is I'm going through the encrypted text and finding the probability of each of the every word and creating a new dictionary.
And then comparing them.
Then comparing it. That's what I proposed.
And now
that's what we have to do. Makes sense.
Yeah, and now I'm creating a new dictionary. Let's call it a keyword dictionary. And for every 2 values that match, I'm creating a new key. Which is
you are doing, exactly. This is what it needs to be done.
And then in the return value, I'm calling the function to return me the de-encrypted text, sending the file S and a new key that is created. So it will de-encrypt using the second function. So I returned the code, but I'm getting some errors.
You can share your screen, we will help you out.
I don't know how. Actually, the error I'm getting is I'm not understanding the concept, like how to create a dictionary and to each key of the dictionary assign a place and later then update the place to a new key.
So I'll tell you
To a
what you
new
can do
string.
is you have the first dictionary in which the original text is there, original frequencies are there.
Yeah.
Okay, you go over the encrypted text, create a frequency dictionary for that one.
Yeah.
Okay, so now in two dictionaries there will be one value common to it. For example, let's say the frequency of A is 39. Okay, makes sense. A is appeared 39 times in the file. And in the encrypted text, let's say J is appeared 39 times. These value matches. So we know that A is mapped to J because their value matches. Make sense?
Yeah.
So this is how we can create the mapping between two.
Okay.
The original string S is also given to us, right?
Sorry?
The original string S, which is not encrypted, that is also given to us now.
But I think we are only allowed to use the dictionary which we created in the second function. The frequency function.
Frequency one, okay.
Yeah.
Okay.
Athava, you want to say something? You wanted to?
Yeah. I was just saying that make one more change that in the definition of cryptanalysis, cryptanalysis substitution, it's S comma D, not just S. We have to give another dictionary. That I'd suggest that we give it as dictionary, not make it global, because a lot of people don't know how to make it global. So rather than having to teach them how to make it global, we'll just give it another dictionary as an input, which is the original distribution of the letters.
Oh, yeah, perfect.
Okay.
Wonderful.
Yeah, and we need to make that change in the document as well, the original document, the .py document, the one that we're going to share in the
do we have the writing? I don't think so. We have the writing access.
We'll take it up with sir. We'll tell him that you have to make
it will only take a minute.
Yeah, or if not, we can tell it personally to the people ourselves in our own teams.
Also works.
Hey, Asana, can you repeat what you just said?
What I said was that in define cryptanalysis substitution, that function that we just were talking about right now, we can't do it using the only E way, right? So we have to give two inputs. One, the encrypted material, and second, a dictionary, which provides the original values, in like
frequency,
how many frequency. So we can match exactly, because this is not enough of a what do you call it, sample set to match exactly according to the Wikipedia values. So we can't directly say that the max will be E, the next one will be T. We can't say that.
Yeah, we already have the values from the first.
So so we have to give that as an input as well. That's what I'm saying. Like S comma D should be the inputs to that function.
So then, to solve this question, what we can simply do is find out the letter which is occurring maximum times in the original string and then in the encrypted string, and then we can subtract the indices of both of them.
Yes, from the alpha variable.
That would be like you
that would make sense.
Or why
why
we are subtracting the value from the index? Because like if I have A occurring the maximum times, and if I have J occurring the maximum times, so obviously A is mapped to J. No.
Yeah.
So we don't need subtraction.
No, we need the subtraction because A is mapped to J. J is, I think, the 10th letter. So A is shifted by 9 places. Now, how do I know this? I know this because J key place is 10 and A key place is 1. So now I know that every letter is shifted by 9. This way I can create the.
But we were doing that already, right?
हाँ, पहले वही कर रहे थे ना? नहीं, हाँ, okay. हम पहले क्या कर रहे थे? We were assuming कि E maximum है.
Yes,
we know that E will be maximum, but we need to prove that we need to take it from the data कि A maximum ही है. E ही maximum है. ये data से लेना पड़ेगा.
This time we don't need to subtract because we know A is maximum. A is mapped to J.
Yeah.
But we already knew from the data that E was maximum, right? We were getting that.
No. It's the example that.
Happy example is the best one, I guess.
Yeah, happy example was the best example. That's what I was gonna say. Harshit gave that example. That's the best example here, because here the frequency of P is the most, but that does not match here. E is not the majority, right? Normally E should be the majority, but here P is the most frequent letter. So
Yeah,
what
got it.
we
Like we are
yeah,
doing it. We're
it is like we
calculating the
are,
frequency there, and then matching it from here, and just equating it just with just one word of it, right?
we can say that this problem is to work on a subset of some whole English language set.
Yeah. Like here, it's a coincidence that E is the most frequent letter because our sample set is big. But what if it was small? That's exactly what Harshit was saying, right?
Actually, can I give out my pseudocode that if anyone can try and work out with an example or try to code?
Yes, please. Yes.
So what I'm doing is
You're in the group, right? Telegram group.
Yeah.
Okay, you're giving the pseudocode as in telling us. Okay. I thought you're copy pasting it. So I was going to say paste it there.
It's not working actually. So I think you can try at your own end. So what I'm doing is I'm going to the whole text. I'm creating a dictionary. Actually, the dictionary was already created. The earlier dictionary in the
Harshit, have you written somewhere? You can share the screen, right?
Okay. Let me share.
Letter description one, no?
Actually, my code isn't working. It's still showing an error, but I'll share.
Yeah, Harshit, you mean the distribution list, right?
Yeah. Let me share.
The letter distribution function, the dictionary which we got, right?
Is it visible now? Is my screen visible?
Visible.
So just go to line number 101. I'm calling this function county. It's letter distribution of A. What it is doing is it is giving back the same dictionary. It is the second function. It is telling me how many times a letter is occurring in the whole text file. It is giving back me the same dictionary.
Yeah.
Now, for what I'm doing is, for every value in the dictionary, I'm dividing it by the length of A.
Okay.
Yeah. So that would give me the frequency of occurrence of that particular letter. And what I'm trying to do is, I will store this in dictionary name is county. Now in line number 114, the last line, I would pass this dictionary also to my function calling. Yeah. Am I making sense?
Yeah, but my question is, do we need the frequency? Once we just, do we need the percentage? Probability. Once we have the frequency, that's enough for us to work with, right? The frequency will be same.
The same thing I'll be doing is, in that function.
You don't need to divide it, is what I'm saying. You don't need that division part.
Yeah, exactly. Division.
We just count and match it.
Yeah, we can just match it. I mean, like.
So are you suggesting me what if two letters are? Then that would be same also, no?
Yeah, that will be same, right?
Yeah.
Like the only benefit that we get is that if we were using this probability somewhere else, that's when it would be make sense. But here it will just like we can like if you want to plot it, graph it, and compare the values, then it would make sense. But otherwise, we don't need to divide it.
So I think here we should assume that each letter has different number of counts.
And because we are going up to 15 digits of float, or maybe more. I don't know the exact.
Whatever the case is, what we just need to look at the topmost one and compare the top maximum and the maximum from the previous dictionary and the maximum from this dictionary, and then find the difference in their indexes, in their keys.
No, what I was trying to say is, whatever is an encrypted file, we are just doing the Caesar cipher, na? So if let's say P is appearing 2500 times in the encrypted text, and let's say A is also appearing 2500 times in the original text, that means P is the letter that is assigned to A initially.
Yes, exactly.
Yeah. So for every letter in the decrypted text, we're comparing
We don't need to do that. Once we know P is connected to A, we just find the difference, and that will be that difference will be constant. So A is connected to P, B is connected to Q.
Yeah.
We know that. Done.
And then we can create. We found the key, and then we can go about doing the same thing.
Yeah.
That we were doing
earlier.
Yeah.
Exactly.
That would work, I think so.
Yeah.
So I think Hardik sir had done with the same function. We can use the same concept there.
Yeah, so what we can do is we create an original list which original dictionary which contains the distribution of letters in the original text, and we create a dictionary, another dictionary which contains the distribution of letters in the encrypted text, and we can define another function that gives us the maximum key value from each of the dictionaries. We call this function inside the cryptanalysis function, and we take those letters and subtract their index values. That would give us the key, and we make a dictionary from that key.
I think that
And
was
we
the
already,
only reason letter distribution was introduced there as a function.
Yeah.
So that it would be used further.
Exactly.
Yeah.
We can use it.
That would be used further. So I think that is the point here.
So again,
We
I just
just
want to
need
ask
to-
one thing. So this code is done into substitution decrypt, right?
Yeah, substitution encrypt. Sorry, decrypt. No, wait.
Yeah.
No.
Yeah, decrypt. No, wait.
So
cryptanalyze substitution. Sorry,
Yeah,
I'm
exactly.
sorry. Cryptanalyze substitution.
And subscription dictionary.
We're just taking the previous code and just matching it with this encrypted text. We're just seeing whatever the key is, we match those two, and then we find
And what we were doing in substitution decrypt, sorry, I kind of lost it.
actually value and then match the
Substitution decrypt. Yeah, basically we had encrypted text. We had the key to decrypt it, and what we did was we reversed the table that we had, and then we again encrypted our already encrypted data and created the unencrypted data, basically negative or negative.
Yeah, so we have the dictionary which we created earlier, from which we encrypted the text. So we are decrypting it using that only.
Yes, reversing that dictionary and then applying it again.
Got it. Thank you.
Sure.
So I'll quickly write the code for this dictionary comparison thing in cryptanalysis. Okay.
Yeah.
And I'll share it with you.
Yeah.
just one thing. It's a little bit after.
Srijita, go ahead.
Go on, Srijita. I think she lost her internet connection. Who else was saying?
Yes, Srijita, go ahead. Please back.
No, she's finished.
Okay, so I was just asking, like, Anushka has already crossed 5 codes, right? She's into second code of Virginia.
Yeah.
Yeah, and like it seems like most of you are going to go ahead like around the same level. Can we later, like after tomorrow, can we discuss it sometime? Because I don't think I'll be able to go beyond this thing, the cryptanalysis.
Yeah, sure.
Sure.
Yeah. We need a session together once again.
Yeah.
Yes, we totally can. Done.
Digita, tell me.
Sorry, my internet connection is very bad. It's speak later.
Okay. Okay, cool. Thank you, guys. I'll code till cryptanalysis till now.
Maybe if you get the idea, you can code the rest part as well. Yeah.
Yeah.
And Atharva was asking you something.
Yeah.
In the protect compare part, we're supposed to do this simple thing of that. So showed us that 0 and 1 and 2 and then kth thing, right? We are shifting it by 1 and then seeing where the spike is happening. Okay.
How many match?
Yeah.
Yeah. So about that, or was that it? Okay. Mehul, are you there?
Yes, Atharva.
Yeah. I just wanted to ask, have we circulated the forms for the hackathon? Like those who want to register for the hackathon? Was there a form?
No forms.
Isn't it too late to ask this question?
Yeah.
No, so someone's asking how to join the hackathon. Where's the link for tomorrow? So I was like also wondering where is the link for tomorrow?
So there was no link. There was a form put out day before yesterday. On basis of that form's response, we have segregated the CC and BB people.
Yeah, right. I did that with you.
Yeah, exactly.
Then they rolled out an email, I guess, right?
Yeah.
Ah,
so
okay, that's what
Nupur
I'm wondering.
Nupur forwarded the Telegram group link on the respective emails.
Okay, right. That's what I was wondering.
Yeah.
What do we do there? Okay. Thanks.
So if you guys are getting like Telegram पे messages or something or mails or something, just tell them. If you are left out, tomorrow we'll send you the link. Tomorrow, take it from Nupur, give it to them.
Yeah, sure.
My ID stopped working.
That's happened to me 10 times. It's so annoying. It just hangs, like for some reason, just nothing works.
You guys should stop using Replit at this point.
I'm not using Replit. I am using Spider. It's not working.
Spider isn't opening today for me. For some reason, Spider decided that it wants to just like kick my butt at the last moment.
Guys,
so I had to
use PyCharm. Use PyCharm.
Go to Anaconda and die Spider.
I had to uninstall it, and I downloaded it again, and still it doesn't want to open. I'm clicking on it 10 times, it still doesn't want to open. I was like, do I have to really use Visual Studio Code for Python? I was like, no, thank
you. You can use Notepad++.
Yeah, I have Notepad++, but then I can't compile it. Can I in Notepad++?
Use GitHub Copilot. Everything is easy.
I have no idea how to use that. I'll look it up.
It's basically an AI which will suggest you the code as long as you're writing.
Wow. That's easy.
So Hardik, can you just explain that dictionary comprehension method once, which you said?
Give me 5 minutes. I'm in middle of writing some code and
yeah. When you are done, yeah.
It's hanged again.
Hardik, how do you run a code in PyCharm? I have never used it.
It's pretty simple. You just create a new project, start coding. There is a dedicated run button. There is a dedicated debug button. Everything
I'm not seeing anything. It's just.
Could you share your screen?
One second.
Meanwhile, Anushka, you there?
Hello.
Yeah. Can you help me with one thing? Can you encrypt the original text of the Sherlock file using the password ABC? Small case ABC.
Yeah.
I just want to match whether my output and your output is the same or not. Because I wrote a code and it spat out some shit, but I do not know whether it is the intended or not.
Have you? Okay, you want me to give you the output now?
Yeah, just the output.
Okay.
Or you could read out the first few letters and I'll see if they match.
Okay.
The key is simply ABC.
Is it DQQUG something?
DQQUG.
UGQUUFIC, right?
FIC.
Yeah.
Right. Okay. I just wanted to make sure that my code worked. although my code is like too lengthy compared to yours. Yours was the perfect code, but you know, different people, different experiences, different lines of thought. Yeah, so Srijita wanted help with PyCharm, right?
I showed you the screen. I think my PyCharm is not properly installed. I think I have to reinstall it.
No, no, no. The only thing that you all ever have to do is create a new project, nothing else.
Yeah, I created a new project. I think it's open, not only opening. Only.
Share the screen again.
One second. So there's nothing here.
Okay. Click on file. Okay, it's showing nothing, right? Click on file. Are you using a Mac?
No, I'm using Windows.
Okay, so it says file. It's not showing the options. Do you have the right version?
That's what I'm wondering. I think it's not properly installed, I guess.
I think what you have installed is not the community edition. It's something like the professional or something.
Yeah, probably.
Can you click the written access full ID at the bottom? That may show the buttons.
Yeah, access full ID, the bottom left corner.
Oh, okay.
You see, it's written access full ID.
Yeah. There it is showing me a number of projects to open. Let's open this one.
Open anyone.
Not opening. Yeah, okay. Yeah, got it.
Just uninstall it and reinstall it once.
Okay.
Should we move ahead with the next functions?
So I think we may be writing functions. I'm currently on the decrypt function. I was just going to start it with decrypt.
Yep, like, can you explain the decrypt one once and also get to it?
The decrypt one?
Sorry?
Like the idea behind the pseudocode behind the decrypt one.
Which decrypt one? There are two.
Is generate Cipher.
Okay. So have you done the encryption one?
Yeah.
So I use the exactly same logic for this. Wait, I'll share my screen. So is it readable?
Yeah.
So in the encryption one, I wrote this line of code. इसमें क्या है कि suppose your password was हाँ ये रहा ना. Suppose your password is ABC. तो इसमें मैंने इंक्रीमेंट कर दिया. मतलब did you understand? इसे मैंने पहले भी एक्सप्लेन
Yes,
करा था.
yes.
हाँ तो डिक्रिप्शन वाले में सेम चीज करी है, बस यहाँ पे माइनस और यहाँ पे माइनस हो गया.
Oh, okay. So we just have to map it back.
हाँ.
Okay.
Did you understand why?
I'll try coding it myself and see.
Okay.
I guess.
Okay. Ask me if you
Yeah,
get
yeah.
in trouble.